Hey, champs of Examsnet. Welcome to the question series of Examsnet. Today we'll be solving Telangana State EAMCET 20 July 2022 Shift 1 paper. So different sections for the paper, physics, chemistry, mathematics. We'll be solving the mathematics question paper in this particular video. Let's start with it. But before that, students do visit our website, www.examsnet.com. There you will find similar type of entrance exam question papers with the detailed solutions and PDFs. So do explore our website and study better. You can also download our app. The link is available in the description box. So let's start with the question number 1 of this paper. Our very best of luck. Here we go. Question number 1, the domain of the real valued function, this is. So domain states all the possible values of x which can be fed into this function. Let's go. So the function is given by this. That means 2x squared minus 7x plus 5 upon 3x squared minus 5x minus 2. For it to be real valued function, this should be greater than equal to 0. It can't be negative, then it will become, if this portion is negative, then this will be imaginary valued function. But we want the real value, so that means this should be greater than equal to 0. Let's factorize it. You will have 2x squared minus 2x minus 5x plus 5 whole divided by 3x squared minus 6x plus x minus 2 should be greater than equal to 0. So you will have 2x, x minus 1 minus 5x minus 1 whole divided by 3x, x minus 2 x minus 2 should be greater than equal to 0. So the two factors will be 2x minus 5x minus 1, 3x plus 1, x minus 2 should be greater than equal to 0. So from looking here, that means the denominator cannot be 0. That means 3x plus 1 cannot be equal to 0, or x cannot be equal to 1 by 3. Similarly, x minus 2 cannot be equal to 0, or x cannot be equal to 2. These two values are not possible. Moreover, if I take the numerator, 2x minus 5, this should be greater than equal to 0, or x should be greater than equal to 5 by 2. Similarly, x should be greater than 1 also. Correct? So this means this line valued function becomes like this. So if I'm having minus 1 by 3 here, 1, 2, and 5 by 2. So this function, see, one thing is for sure that 1 by 3 and 2, these are the two breaking points, because x cannot, these are the points in which the function becomes discontinuous. Okay, these are the 2 points which are not possible values for x, that's for sure. Now, moreover, towards the left side of minus 1 by 3, the function is increasing. Towards the left side, it's decreasing. Here, between 1 and 2, it's increasing again, decreasing, and increasing in this side also, because this is positive on this side, negative, positive, negative, and positive towards the right of 5 by 2. Okay, so looking at this one, what will be the domain? Let's say domain will belong to, see, over here it's increasing, so minus infinity to minus 1 by 3, these are two open intervals, union, closed 1, because 1 is included over here, and open 2 is not included, union 5 by 2, this is included, infinity. So this is the domain for the function, given function. Let's check with the options. You have option A as the correct answer. Hope you got this. Next is question number 2. The range of the real valued function. Now this time you have to find out the range. In the previous one, we found the domain. I hope you are aware, like domain and range. So domain is this, and range denotes the possible values of y for the given value of x. Okay. Now the given function is mod of x plus x minus 2 plus x minus 3. Now we know that x minus a, for x minus a plus x minus b if fx is equal to this. The minimum value of fx we get either at x is equal to a or x is equal to b. So for this function, if x is equal to this, the minimum value possible will be at f2 or at f3. At f2, this will be 0 plus mod of -1, that is equal to 1. And this will be 1 plus 0, that is equal to 1. So that means the function is going to have minimum value of function will have the minimum value as 1. And what about the maximum value? Maximum value will be infinity at x is equal to infinity. Whenever you will put x is equal to infinity, fx is going to give you the output as infinity. Therefore, function maximum value is this, infinity plus infinity, that's going to give you infinity. Therefore, range is this. Okay. And we have option B as the correct answer. Hope you got this. Next is question number 3. This is a matrix problem. A is this matrix, A plus A transpose multiply A minus A transpose is. So you are given this A matrix. Let's write down the transpose of this matrix. It is 1, 4, 3, 2, 3, 4, 2, 3, 2, 5. This is a transpose matrix. So now let's perform this. A plus this multiply this. So let's add them and subtract them and then multiply both of them. So A plus, this is going to give me 2, 4 plus 2, 6, 3 plus 3, 6, 4 plus 2, 6, 3 plus 3, 6, 6, 6, 6, 10 multiplied by 0, 2, minus 2. 0 minus 2, 0. Then 2, 0, minus 2, 0, 2, 0. Let's multiply both of them. You know the formula, first row into first column. So let's go for this. So you will have 0 plus 12 plus 0 minus 4 plus 0 plus 12, 0 minus 12 plus 0. Then 0 plus 12 plus 0 minus 12 plus 0 plus 12, 0 minus 12 plus 0. So 0 plus 12 plus 0 minus 12 plus 0 plus 20, 0 minus 12 plus 10, 0, sorry. So this is gonna give me 12, 8, minus 12, 12, 0, minus 12, 12, 8, and minus 12. Let's take 4 common. So you will have here 3, 2, minus 3, 3, 0, minus 3, and 3, 2, minus 3. Right? So this is the value. Let's check with the options. You have, yes, option A is the correct answer. Hope you understood. Next is question number 4. Again, a matrix problem. Fx is given by this matrix. You have to find out f of 1, f of 5. So this is pretty easy. But the thing is, if I'll directly put x is equal to 5 in the question, it will be a little lengthier. So let's take use of the matrices determinant formulas, operations. I'll use this one and I'll apply some operations. Let's transform R3 to R3 minus R1 and R2 to R2 minus R1. So this becomes, So R3 minus R1, I'll write R1 as such. Now R2 is R2 minus R1. This gives me 2, 3, and 4. Then R3 minus R1, this gives me 6, 8, and 10. At x is equal to 5, now it's pretty easy. This matrix becomes 5, 6, and 8, 2, 3, and 4, 6, 8, and 10. Now let's open it. You will have 5 into 30 minus 32, 6, 20 minus 24, 16 minus 18. This gives you minus 10 plus 24 plus this. That's minus 2 as the answer. Option C is the correct answer. Hope you got this. Next is question number 5. Again, a matrix thing. A is this if A inverse is equal to alpha A squared plus beta A plus gamma identity matrix, then alpha, beta, gamma are real numbers and identity is a 3 by 3 identity matrix. Then 17 alpha plus 5 beta plus gamma is equal to. So basically I have to find out alpha, beta, gamma and you will get to know the answer. Okay. Now, A matrix is 2, 1, 1, 0, 1, 0, 1, 1, and 2. You are given A inverse is equal to alpha A square plus beta A plus gamma identity. Let's multiply both the sides with A matrix. Both sides by A. You will have identity matrix is equal to alpha A cube, beta this, gamma identity matrix into A will give you A only, right? So for matrix A, determinant A minus lambda I is equal to 0, which gives you 2 minus lambda 1, 1, 0, 1 minus lambda 0, 1, 1, 2 minus lambda is equal to 0. Now let's find out the determinant. 2 minus lambda into this minus 1 into 0 plus 1 lambda minus 1. Okay. Is equal to 0. So this is gonna give me 1 minus lambda into 2 minus lambda whole square, which is a square plus b square minus 4ab minus 0. So plus lambda minus 1 is equal to 0. Let's open it further. 4 plus lambda minus 4 lambda squared minus 4 lambda minus 4 lambda minus lambda cube plus 4 lambda squared plus lambda minus 1 is equal to 0. You will have here minus lambda cube minus 5. Give me a minute. This is minus 8. 4 lambda cube, 4 lambda square. Okay. So minus 8 plus this, it's going to give me 7. Okay. 5 lambda square minus 7 lambda plus 3 is equal to 0. So this will be 1 by 3 lambda square minus, here was plus, minus 5 by 3 lambda square plus 7 by 3 lambda is equal to 1. How? Multiplying both sides by minus 1 by 3. All right. So now this is the one. Now let's compare it with the given one, which was alpha a square This is actually we took for this. Okay. Now this was equal to identity. So now let's compare it with this one. You have alpha is equal to 1 by 3. Beta is minus 5 by 3. Gamma is 7 by 3. Right? So you will have here, we had to find out 17 alpha plus 5 beta plus gamma. This gives you 17 upon 3 minus 25 upon 3 plus this. So this is going to give me 24 minus 1 upon 3. This is the answer to the question minus 1 upon 3, and option B is the correct answer. Hope you understood. Then let's move to the next question number 6. For a system of simultaneous linear equation, AX is this and adjoint of A matrix is this, and determinant is greater than 0, then X is equal to. So in this question, you are given these things. AX is this, adjoint is this, and determinant of A is greater than 0. So now using this formula, that adjoint of A determinant is the determinant of A raised to power n minus 1, where n is the order of the matrix. Right? So that means determinant of 1 minus 1 minus 1, 1, 1 minus 1, 1, 1, 1 is equal to determinant of A raised to power, this is 3 by 3 matrix, so raised to power 2. That means determinant of A square is, let's find out determinant of it. You will have 1 multiply 2 plus 1 multiply 2 minus this. Okay, so this comes out to be 4. And A determinant is equal to 2 because it's given, see, it's actually plus minus 2, but because it's given that determinant is greater than 0, so that means it's 2 only. Okay, now X, it was given in the question that AX is equal to 112. That means X is equal to A inverse into 112, right? This is equal to adjoint of A into determinant of A, 112. So X is given by 1 by 2 into adjoint of A. See, it is this one, adjoint of A. 1 minus 1, 1, 1, 1 minus 1, 1, 1, 1 multiplied by 1, 1, 2. This gives you half into 1 minus 1 minus 2, 1 plus 1 minus 2, 1 plus 1 plus 2. So this is equal to half into minus 2, 0 and 4. That's going to give me minus 1, 0 and 2. This is the value for X matrix minus 1, 0, 2. Minus 1, 0, 2 is option A. Hope you understood. Option A is the correct answer to the question. Next is question number 7. If X belongs to the limit interval 0 to 2 pi, where sin X plus iota cos 2X and cos X plus iota sin 2X are conjugate to each other. Okay, so here you are given that X belongs to closed 0 to pi interval and sin X plus iota cos 2X and this, they are conjugate to each other, which means sin X plus iota cos 2X is equal to cos X minus iota sin 2X conjugate. That gives you sin X plus iota cos 2X is equal to cos X plus this, because these two are the conjugate of each other. Okay. So now let's set it to 1. Now on comparing both side of equation 1, the real part with the real part and the imaginary with the imaginary part, you get sin x is equal to cos x and cos 2x is equal to sin 2x. This gives you, see, sin x and cos x, they are equal at x is equal to pi by 4 or 5 pi by 4 and so on. Similarly, over here also you have tan 2x. See, here you had tan x is equal to 1. So that means x could have been pi by 4 or 5 by 4 or so on. Similarly, here tan 2x is equal to 1. This gives you 2x maybe pi by 4 or 5 by 4 or next so on, right? So this gives you x may be equal to pi by 8 and 5 pi by 8, this and so on. Okay, not so on actually, 13 pi by 8. Let's check with the options. We definitely have option C, A as the answer. Question number 7. If x belongs to the interval 0 to 2 pi, sin x plus iota cos 2x and cos x minus iota sin 2x are conjugate to each other, then for what value of x will be there? Now, x belongs to the enclosed interval, this, right? Also, you are given that sin x plus iota cos 2x and cos x minus iota sin 2x, they are conjugate to each other. So that means this is true, correct? So this can be written as sin x plus iota cos 2x is equal to cos x plus iota sin 2x. Now equating real parts and the imaginary parts, you have sin x is equal to cos x and cos 2x is equal to sin 2x. Here you have tan x is equal to 1 and also tan 2 of x is equal to 1. That means x is equal to pi by 4 or 5 pi by 4 or 9 pi by 4 or 13 pi by 4. And here 2x is equal to similar thing, pi by 4, 5 pi by 4, 9 pi by 4, 13 pi by 4. But see, either x can be equal to this, a multiple of 2, like multiple of x with 2 is also the same, which is not actually possible. This is not possible. There is no common value of x which satisfy both the conditions. So that means we have x is null. Right? Because no common value of x is there which is satisfying both of them. And we have option D as the correct answer. Hope you understood. Next, question number 8. So now a complex number problem before us. It says if x plus iota y modulus is equal to root of x squared plus y squared, then you have to find out the value of this expression. Okay, let's write it down. Mod of 1 minus root 3 iota 9 plus root 3 plus iota raised to power 9 is equal to, I'll pick up the first thing. 1 minus root 3 iota raised to power 9. I'm taking iota common from here. So iota raised to power 9, I can write it as 1 upon iota minus root 3. So, iota raised to power 9, this is actually equal to, wait a minute. Okay, so iota raised to power 9 is equal to iota square into 4 into iota. So this is minus 1 raised to power 4 into iota. That is equal to iota. So now you can write it as iota raised to power. 1 can be written as minus iota square upon iota minus 3 raised to power 9. So this is equal to iota raised to power minus iota minus root 3 this. So this will be minus iota, actually iota into minus 1 raised to power 9 root of 3 plus iota raised to power 9, that is equal to minus iota into root 3 plus iota raised to power 9. Now let's get back to our equation 1 and fill it in equation 1. In equation 1, you will get 1 minus root 3 iota raised to power 9 plus root 3 iota raised to power 9. Mod of it is equal to mod of, that was equal to minus iota this plus this. I'll take root 3 plus iota raised to power 9, 1 minus iota. This was whole under the mod, right? So that's it. Now let's see, you already are given that mod of x plus iota y is equal to x squared plus y square root. So this can be written as 1 square plus root 3 square root whole raised to power 9 multiply root of 1 plus minus 1 square. This is going to give me root of 4, that is equal to 2 raised to power 9 multiply root of 2. So that's it. 2 raised to power 9 multiply 2 raised to power 1 by 2. That is 2 raised to power 19 by 2. So this is the answer to our question, 2 raised to power 19 by 2, option D. Hope you understood this question. Then next is question number 9. If 1 omega and omega square are cube roots of unity and 1 alpha, alpha square, alpha cube are fourth roots of unity in the usual notation, then what is this expression equal to? First thing, if I say some x cube is equal to 1, then x may be 1 or omega square, and x raised to power is 4 is also equal to 1. This gives me x raised to power 4 minus 1 is equal to 1, or x is equal to, you will have x as plus minus 1 or plus minus iota, right? So the roots are 1 iota minus 1 minus iota. That is alpha is equal to I, because it's given 1 alpha, alpha, alpha cube are fourth roots of unity, correct? Then alpha plus alpha into omega, alpha cube, omega square. This is equal to alpha into alpha omega minus. Now, this can be written as omega square upon alpha. Why? Because see, alpha is equal to iota. That means alpha cube is equal to iota cube, which means alpha cube is equal to minus iota. Right? I think add C, iota square into iota. Iota square is minus 1. So alpha cube can be written as minus iota, which further is alpha cube is equal to minus alpha. Right? So now alpha into 1 plus omega minus omega square upon alpha is equal to this. Right? So omega square, I'm taking this on the left hand side. Omega square, rather minus omega square, will be alpha plus 1 upon alpha is equal to minus omega square, alpha square plus 1 upon alpha, which will give you omega square minus 1 plus 1 upon iota is equal to 0. So this is what we were looking for, right? That means we have option C as the correct answer. Hope you got that. Next is question number 10. It says if alpha and beta are roots of the quadratic equation x squared plus bx plus c, is equal to 0 such that this and this are true, then b plus c is equal to. So you are given x square plus bx plus c is equal to 0. Then the two roots are alpha and beta. According to that, the sum of the roots is equal to minus b upon a, and product of the roots is equal to c upon a. A is actually equal to 1, so you can say alpha plus beta is equal to minus b, and this is equal to c. Okay. Also, so let's solve it. Alpha square plus beta square is equal to 5. You are given that. So solving this, alpha square plus beta square is equal to 5. You can say this is alpha plus beta whole square minus 2 alpha beta is equal to 5. That means minus b square minus 2c is equal to 5, or b square minus 2c is equal to 5. This is equation 1. Right. Next, you are also given that alpha cube plus beta cube is equal to 9. Second one I'm picking. This is equal to 9, which gives you alpha plus beta into alpha square plus beta square minus alpha beta is equal to 9. Alpha into beta, it was equal to minus b. Alpha square plus beta square, 5 minus, that was equal to a, yeah, c. Okay. So this is also equal to 9, which gives you, okay, fine. So let's keep it till here only. This is equation 2. Now from equation 1, you have c is equal to b squared minus 5 upon 2. Let's fill in this one. So minus b, 5 minus b squared minus 5 upon 2 is equal to 9, which gives you minus 5b plus b into, okay, I'm opening. So plus b into b squared minus 5 upon 2 is equal to 9. So let's take the LCM also. This will be minus 10b plus b cube minus 5b is equal to 18, which gives you b cube minus 15b minus 18 is equal to 0. So that means on solving, you will get the root over here will be b is equal to minus 3. One of the roots you will solve, b is equal to minus 3. Actually, this happens with the practice. The more you practice, the more you can do easily these type of sums. Okay. So this further can be written as b plus 3, factorizing it. B square minus 3b minus 6 is equal to 0, which gives you that b is equal to minus 3, or c was this. So b is minus 3, which gives you 9 minus 5, that is equal to 4. 4 divided by 2 is 2. So c comes out to be 2. And you had to find out the value of b plus c. So we got the value of b and c. Let's add both of them. B plus c gives you minus 1. So we have option C as the B as the correct answer. Hope you got that. Let's move to the next question, number 11. The set of all real values of this expression for all x belonging to real numbers except minus 2 and 1 is. Okay, so first is, let's say y is equal to this, x squared minus x plus 2 upon x squared plus x minus 2 for all x belonging to real numbers except this. Let's do the cross multiplication. You have yx squared plus yx minus 2y is equal to x squared minus x plus 2. This gives you y minus 1. I'm taking this x squared on the left hand side. So y minus 1 x squared plus y plus 1 x minus 2 y plus 1 is equal to 0. So for all x belonging to the real numbers. Okay. Now here, discriminant should be greater than equal to 0. And discriminant, it's given by b square minus 4ac. So that means y plus 1 square minus 4 into y minus 1 into this should be greater than 0. So y plus 1, I'm taking common from there. You will have y plus 1 minus this will be 8. Y minus 1 should be greater than equal to 0. Okay. So, all right. Writing it clearly now. Fine. So that means, see, there are two things. From here, either solve it, you will have 9y minus 7. These are the two factors. So that means y should be greater than equal to minus 1. At the same time, y should be greater than equal to 7 by 9. Okay, for having the positive values. So if I plot it on the graph, so if minus 1 is there, 7 by 9 is here. So towards the left side of it, the values are increasing, and also towards the right side of it, the values are increasing. And here the values are decreasing, right? The graph is decreasing, and on these two sides, it is increasing. For that, the y will belong to minus infinity, minus 1, closed union, this. So that's the answer. Option C is the correct answer. Hope you got this. Next is question number 12. It says if alpha, beta, gamma are roots of this equation, then alpha cube plus beta cube plus gamma cube is. So equation is x cube minus 9x square plus 23x minus 15 is equal to 0. Then you know the sum of the roots is given by, roots are alpha, beta, gamma. So sum of the roots is given by minus b upon a. So minus of minus 9 upon 1 gives you 9. Also, sum of product of the roots alpha beta plus beta gamma plus gamma alpha is equal to c upon a, which is equal to 23 upon 1. The last one, the product is equal to minus of d upon a. So minus of minus 15 upon 1 is equal to 15. Okay, these three things are there. Now let's get to what we had to find out. Alpha cube plus gamma cube plus alpha cube plus beta cube plus gamma cube. The formula for this, alpha cube plus beta cube plus gamma cube minus 3 alpha beta is equal to alpha plus beta plus gamma, alpha square, beta square, gamma square minus this. So this is what we had to find out. Leaving it, I'll fill in the rest of the values. Okay. So alpha cube plus beta cube plus gamma cube minus 3 into 15 is equal to 9 into, okay. See, the next one, alpha squared plus beta squared plus gamma square. This further can be written as alpha plus beta plus gamma square minus 2 alpha beta, beta gamma, gamma alpha minus alpha beta, beta gamma, gamma alpha. So this is equal to is equal to 9, and that was equal to 9. This is equal to 9, 9 square. And see, these two are like terms, so minus 3 alpha beta. So this alpha cube, beta cube, gamma cube is equal to 45 plus 9 into 81 minus 3 into alpha beta, beta gamma, and gamma alpha. This is equal to 23. 45 plus 91, 9, 81, 69. So this is equal to 45 plus 9 into 12. So this is going to give me this. So 153 is the answer. Okay. 153, option C stands to be the correct answer. Hope you got this. Then let's move to the next question, number 13. If alpha, beta and 2 beta are real roots of this equation and x belongs to R minus, C, sorry, k belongs to R, all the real numbers except 0, then 14 beta is equal to. You are given alpha, beta and 2 beta. They are the real roots of this equation, x cube minus 9x square plus k is equal to 0. So see, if they are the real roots of this equation, that means the sum of the roots is given by minus b upon a, that means 9. Also, alpha beta plus beta into 2 beta plus 2 beta into gamma is equal to 0. Yeah. Okay, this is equal to 0. Also, the third one. See, from here, the third one. So, alpha into beta into 2 beta is equal to minus k. This gives you 2 alpha beta square is equal to minus k. Here you have alpha plus 3 beta is equal to 9. And this becomes 3 alpha beta plus 2 beta square is equal to 0. Okay, so we have these three equations. Let's take beta common from here. You will have a 3 alpha plus 2 beta is equal to 0. And these ones. Okay, these three equations are there. Correct. See, over here, one thing is for sure that beta is not equal to 0. Because k is not equal to 0. If k is not equal to 0, that means beta is not equal to 0. Okay. So, 3 alpha plus 2 beta will be equal to 0. Right? So, let's name it as number 2 and this as number 1. I have two variables, two equations. Let's alpha plus 3 beta is equal to 9. So multiply this equation with 1. Okay, let's leave it. Let's multiply this equation with 3. You will have 3 alpha plus 9 beta is equal to 27. Also 3 alpha plus 2 beta is equal to 0 minus minus minus. This will cut and 7 beta is equal to 27, which gives you beta is equal to 27 upon 7. You had to find out 14 beta. So that's going to be 54. All right. So 54, which is option D, is the correct answer. Hope you understood this question. Next is question number 14. The sum of all distinct roots of this equation are. So let's write down the roots. Equation x raised to power 5, this, this is equal to 0. So one of the factors is x minus 1 because, okay, so x minus 1, if I'm dividing this whole equation with x minus 1, I will get the quotient as x raised to power 4 minus 2x raised to power 3 plus 3x square minus 2x plus 1 is equal to 0. So let's take x square common then. X minus 1 into x square minus 2x plus 3 minus 2 upon x plus 1 upon x square is equal to 0. Next, x square minus 1, x square. So I'll combine this x square plus 1 upon x square minus 2 x plus 1 upon x plus 3 is equal to 0. So further, this is x minus 1 into x square. So this is, okay, I can do one thing. I'll write this as x plus 1 upon x whole square minus 2 into x plus 1 upon x plus 3 is equal to 0. This gives me further x minus 1 into x square, x plus 1 upon x whole square minus 2 into x plus 1 plus 1 is equal to 0. So x minus 1 into x square. This is something a square plus b square minus 2ab. So this is equal to x plus 1 upon x minus 1 whole square is equal to 0. X minus 1 into x square. This is x square minus x plus 1 is equal to 0. Right? Now, x minus 1 is equal to 0 and x is equal to 1. Or x square minus x plus 1 is equal to 0, which gives you the two roots of x as 1 plus minus 2 upon 2. That means it will be 3 by 2 or minus 1 by 2. So the distinct roots will be 1, 3 by 2, minus 1 by 2. These are three distinct roots, and sum of the roots is equal to 1 plus this minus this, that is equal to 2. So the answer to the question is option B. Hope you understood this. Let's move to the next question. Question number 15. It says x raised to power 4 plus 1 is equal to 1 by a into x plus 1 raised to power 4 is a reciprocal function. Okay, then which of these following is true? You are given that x raised to power 4 plus 1 is 1 by a, x plus 1 raised to power 4. This is a reciprocal equation. Therefore, we can replace x by 1 by x, provided x is not equal to 0. Okay, so let's replace it. You can write it as 1 by x raised to power 4 plus 1 is equal to 1 by a 1 by x plus 1 whole raised to power 4, which gives you this is equal to 1 by a 1 plus x whole upon x, this raised to power 4. So this can be written as 1 plus x raised to power 4 upon x raised to power 4 is equal to 1 by a 1 plus x raised to power 4 upon this. So these will cancel, and 1 plus x raised to power 4 is equal to 1 by a 1 plus x whole raised to power 4. Now at x is equal to 0, if I put this, then a will be equal to 1. But as x, we started with the condition that x cannot be 0. Therefore, a belongs to all the real numbers except 1. So this is our answer. A belongs to all real numbers except 1. That means option B is the correct answer. Hope you understood. Question number 16. Let A, B, C belong to natural numbers and A plus B plus C is equal to 5. Let L, M be the least and the greatest value of this expression respectively. Then the difference between the maximum and the lowest value is equal to what? So you are given that there are three numbers such that sum of them is equal to 5. And they all belong to the natural numbers. Now it says L is the least value of 2 raised to power a, 3 raised to power b, 5 raised to power c, and m is the greatest value of 2 raised to power a, 3 raised to power b, 5 raised to power c. Now, the possible values of a, b, and c can be 1, 1, 3, 1, 3, 1, 3, 1, 1, or 1, 2, 2. Okay, So let's pick up each and every pair. I have 4 pairs. Let's pick up the first one. So if I'm taking 1, 1, 3, first pair. 4, 1, 1, 3. This expression will be equal to 2 raised to power 1, 3 raised to power 1, and 5 raised to power 3. That is equal to 750. Now, for 1, 3, 1. This is equal to 2 raised to power 1, 3 raised to power 3, and 5 raised to power 1, which is equal to 270. Actually, there are some further values also, 1, 2, 2, and I have 2, 1, 2 also, 2, 2, 1. So these are a few values possible. Now, for 1, 3, 1, I have the value of this expression as 270. For 3, 1, 1, this value will be 2 raised to power 3 into 3 into 5, which is equal to 120. For the next one, 3, 1, 1, I have this 1, 2, 2, that's equal to 2 raised to power 1, 3 raised to power 2, 5 raised to power 2, which is equal to 450. The next one, 2, 1, 2, this is 2 raised to power 2, 3 raised to power 1, 5 raised to power 2, which is 300. The next one, 2, 2, 1, 2 raised to power 2, 3 raised to power 2, 5 raised to power 1, which gives you 180. Okay, so from here, you can easily say the least value is 120 and the maximum or the greatest value is 750. So M minus L, that's got to be this. Or I can say this also. I'll pick up this one. 2 raised to power 1 or 2 only. That's equal to 2 multiply 3 multiply 5 raised to power 3 minus 2 raised to power 3 into 3 into 5. So I'll take 2 into 3 into 5 common from here and left with 5 square minus 2 square, that is equal to 30 multiplied 25 minus 4, so 21 into 30. Okay, I don't need to solve, sorry, I have answered in this form only, so I will not solve it. Okay, so this gives me, let's keep it as such only. 8. Let's put a margin. Okay, so this is equal to 2 into 3 into 5 into 21, which gives you 2 into 3 into 5 into 3 into 7. That is equal to 2 into 3 raised to power 2 into 5 into 7. So this is the answer to the question. Okay, and let's check with the options. We have option, wait, 2 raised to power 1, 3 raised to power 2. 2 raised to power 1, 3 raised to power 2, 5 into 7. We have option A as the correct answer. Hope you understood. Then let's move to the next question. Question number 17. The number of positive divisors of 360, which are multiples of 3, is. So 360, let's write down the multiples first. This can be written as 8 multiply 9 multiply 5, which is 2 raised to power 3 into 3 raised to power 2 into 5. So the number of positive divisors which are multiple of 3. The number of, first of all, let's write down the number of positive divisors only. Number of positive divisors will be given by, if I'm just talking about the number of positive divisors, this will be given by 3 plus 1, 2 plus 1, 1 plus 1. But now there is one more condition, that they should be multiple of 3. So number of positive divisors that are multiples of 3 will be given by 3 plus 1 into, see, 3 raised to power 2 is there, so 2 plus 1. Here I will have minus 1 also, which will give me 4 multiplied 2 multiplied 2, that is 16. So we have option A as the correct answer. Hope you got that. Then let's move to the next question, number 18. It says, this whole expression is there. You have to find out the value of it. Let's start. I have 1 by 8 minus 7 upon 8 multiplied 12 plus 7 multiplied 10 upon 8 multiplied 12 multiplied 16 and so on. So here I'll do what? Add and subtract 3 by 4. So 3 by 4 plus 1 by 8 minus this plus 7 multiplied 10 upon 8 multiplied 12 multiplied 16 and so on. Okay, this whole thing minus 3 by 4. Now this further 3 by 4 can be written as 1 minus 1 by 4 plus this minus this plus 7 by 10 upon this minus 3 by 4. So further 1 minus, I'll write down 1 by 4 as 1 by 3 into 3 minus 3 by 4 plus 1 by 8. So I want to write it again like 1 by 3 multiply 3 by 4 multiply 3 by 4. Sorry, 4 by 3 multiply 3 by 4 whole square. This whole is divided by, see, 4 and 1, 4 will cancel from here and 3's will cancel. I'll be left with like 1, 2 is pending to complete a 8 over here. So here will be 2 factorial. Okay. Similarly, minus 1 by 3 into 4 by 3 into 7 by 3 into 3 by 4 cube whole divided by 3 factorial. Okay. Next, I'll continue plus 1 by 3, 4 by 3, 7 by 3, 10 by 3, 3 by 4 raised to power 4 upon 4 factorial. This continuous minus 3 by 4. So this can be written as, this is equivalent to 1 minus 1 by 3, 3 by 4 plus 1 by 3 into 4 by 3 can be written as 1 by 3 plus 1 multiply 3 by 4 square whole upon 2 factorial minus 1 by 3 into 1 by 3 plus 1, 1 by 3 plus 2 into 3 by 4 whole cube upon 3 factorial plus 1 by 3 into 1 by 3 plus 1, 1 by 3 plus 2 plus 3 multiply 3 by 4 upon raised to power 4 upon 4 factorial, so on, minus 3 by 4. Now this whole is equal to, this is the formula for 1 plus 3 by 4 raised to power minus 1 by 3. Minus 3 by 4 already exists. So this is 1 plus 3 by 4 is 7 by 4 raised to power minus 1 by 3 minus 3 by 4. This is equal to, like, I'll reciprocate to remove the negative sign. So root of 4 by 7, cube root of 4 by 7 minus 3 by 4. This is the correct answer to the question. So we have option B as the correct answer. Hope you understood. Next is question number 19. If this expression is equal to a upon x plus 7, b upon x plus 7 square plus c upon x plus x minus 7 cube, then 2a minus 3b plus c is equal to what? Okay, so you are given 2x cube minus 3x plus 5 whole upon x minus 7 cube is equal to this. Let's write. Okay, so now let's take the LCM. You can say 2x It is square, not cube. Minus 3x plus 5 is equal to a into x minus 7 square b into x minus 7 plus c, because the denominators will cancel each other. Okay. So now let's put x is equal to 7 on both sides. Okay. So if you're putting x is equal to 7, you will have 2 into 49 minus 3 into 721 plus 5 is equal to 0 plus 0 plus c, or this is gonna be 98 minus 16 is equal to c, which will give you the value of c as 82. Okay, we got the value of c as 82. So therefore, this equation becomes 2x squared minus 3x plus 5 is equal to a into x minus 7 square b into x minus 7 plus 82. So further, let's open it up. 2x square minus 3x plus 5 is actually equal to ax square minus. So when you will bring the like terms together, you will have ax square minus 14a minus b into x plus 7 into 7a minus b plus 82. So now you are given that this is equal to, okay, this one, fine. So let's compare both the sides. Now you will have a is equal to 2, 14, a minus b is equal to minus 3. We already have a is equal to 2, so this is going to be 28 minus b is equal to minus 3, or 25 is equal to b. Correct? B's value I got as 25 and C already we have as 82. So what we had to find out in the question, 2A minus 3B plus C. So 2A minus 3B plus C. 2A was equal to, just calculated, it was 2. So 3 into 25 plus C's value was 82. This gives me 4 minus 75 plus 82, that is 11. So we have option C as the correct answer. Hope you got this. Let's move to the next question. Question number 20. If 3x squared plus ax upon 3 upon 2x plus 3 into x squared plus 2 is equal to this whole expression, then a multiply capital B plus C is equal to. Okay, so let's start it from here only. I'll take the LCM on the left and right hand side and proceed with the sum. 3x square plus ax plus 3 whole divided by 2x plus 3 x square plus 2 is equal to 3 into x square plus 2 plus 2x plus 3 into bx plus c whole divided by 2x plus 3 into x square plus 2. They will cancel out. And you will have 3x square plus ax plus 3 is equal to, let's open it up also. So 3x square plus 6, that is going to give me 2bx square plus 2cx plus 3bx plus 3c. Let's combine the like terms. You will have, sorry, not here is plus, not is equal to. So you will have 3 plus 2b x square plus 2c plus 3bx plus 3 into c plus 2. This is equal to 3x square plus ax plus 3, which gives you 3 plus 2b is equal to 3. Let's compare the coefficients now. Compare the coefficients. So you will have 3 plus 2b is equal to 3. This is equal to 3, which gives me b is equal to 0. Next, a is equal to 2c plus 2b, which gives me a is equal to 2c. Next, 3 is equal to P this. So that gives you C is equal to -1. Let's fill in over here. You will get A is equal to -2. I got the value for capital B and the capital C and small a, right? You have to find out this. Small a into B plus C, which gives you -2, 0, -1. That is equal to 2. So the answer to the question is option D. Hope you got this. Let's move to the next question. Question number 21. If sine A plus B multiplies sine A minus B plus cos A plus B cos A minus B is equal to 1 by 2 and B lies between 0 and pi by 2, then the value of B is equal to. Okay, you know the two formulas. Let's write down the formulas first. Sine A plus B, I hope you know this. Sine A cos B cos A sine B. Similarly, sine A minus B will have a negative sign here. Cos A plus B is equal to cos A cos B minus sine A sine B, and for cos A minus B, I'll have a plus sign here. Okay, in the middle of the two. Now, let's proceed with the sum. So sine A plus B into sine A minus B plus cos A plus B into cos A minus B. This is of the form cos A minus B, right? Where, what is the first expression? It is A plus B. The first term is A plus B. And the second one stands to be A minus B. Okay. I hope you understood this. See, if I'm taking this A plus B is equal to some X and A minus B is equal to some Y. So this is sine X, sine Y plus cos X, cos Y, which equates to this identity cos X minus Y, right? So this is the given expression, which was cos sine A plus B sine A minus B plus cos A minus B. This is something like cos sin X sin Y plus cos X cos Y, which is equal to cos A minus the second one, which is going to give me cos 2B. Now in the question, this is given to be 1 by 2. That means cos 2B is 1 by 2 at pi by 3. That gives me 2B is equal to pi by 3 or B is equal to pi by 6. So this is the value for B. This is what we needed. B is pi by 6, which is option A. Hope you understood this. Then let's move to the next question. Question number 22. It says 1 upon sine 250 plus root 3 upon cos 290 is equal to. So 1 upon sine 250 can be written as a sine of 180 plus 70 plus root 3 cos 360 minus 70. This gives you, see, you must be aware of the two identities, that's sine pi by theta, sorry, pi plus theta is equal to actually minus sine theta, and cos 2 pi minus theta is equal to cos theta only. So using these two identities, you can write it as the above expression will be 1 upon minus sine 70 plus root 3 upon cos 70. Let's take the LCM. You will have minus sine 70 cos 70 is equal to minus cos 70 plus root 3 sine 70. That's root 3 sine 70 minus cos 70 upon minus sine. Give me a minute. There is a slight mistake because I had taken the minus in the this, so here will be minus. And see, I'll do one thing. Is this I'll do this step all over again. So you can write it as minus 1 upon sine 70 degree plus root 3 upon cos 70 degree. That's equal to question number 22. 1 upon sine 250 plus root 3 upon cos 290 is equal to what? Okay. So let's start it from here. 1 upon sine 250 can be written as sine 180 by plus 70 degree plus root 3 upon cos 360 minus 70 degree. You know the two identities, sine phi plus theta is equal to minus sine theta, and cos 2 pi minus theta is equal to cos theta. Okay, so this can be written as minus 1 upon sine 70 plus root 3 upon cos 70 degree. Let's take the LCM. You will have sine 70 cos 70. This will be root 3 sine 70 degree minus cos 70 degree. Okay. So now let's multiply the numerator and the denominator with 2. So you will have here, okay, one thing more, I will multiply further with 2. Root 3 by 2 sine 70 minus 1 by 2 cos 70 whole divided by, so now this is 2 sine A cos B, which is equal to sine 2 into 70 degree. Okay. Now cos 3 by, root 3 by 2 is equal to, if I'm taking it in the terms of cos, this is equal to cos 30 degree, and 1 by 2 is equal to sine 30 degree. So this is equal to 4 cos 30 sine 70 minus sine 30 cos 70 degree whole divided by sine of 140 degree. Okay. So now further, this is cos A sine B minus sine A cos B, or you can say sine A, if I'm taking this as A and this as B, sine A cos B minus sine cos A sine B, using sine A minus B is sine A cos B minus cos A sine B. You will get this expression to be equal to 4. So this is equal to sine 70 minus 30 upon sine 140. So 140 can be written as 180 minus 40. This is equal to 4 into sine 40 upon sine 40. That is equal to 4. Okay. So the answer to the question is option B. Hope you understood this question. And let's move to the next question number 23. It says if A plus B plus C is equal to pi by 2, then this whole expression is equal to what? So let's start. You have to find out the value of this expression. We are given that A plus B plus C is equal to pi by 2. Now, root of 2 cos pi by 4 minus A, root of 2 cos pi by 4 minus B, this thing, cos pi by 4 minus C plus 1. I'll not touch the first two. I'll leave them as such. I'll take root 2 common. So cos pi by 4 minus A plus this root 2 I'm taking. Now see, this is cos A minus B. So that's equal to cos pi by 4. Cos pi by 4 is 1 by root 2 multiply cos C minus sin A, which is again this into sin C. Sorry, plus over here, right? So this can further be written as root 2. See, over here you are having cos pi by 4 minus A. Let's open up this also. Root 2. So this is cos x plus cos y, that is given by 2 cos. Okay, this is equal to 2 cos pi by 4 minus A plus pi by 4 minus B whole divided by 2 into cos question number 23. If A plus B plus C is equal to pi by 2, then this whole expression is equal to what? You are given that the sum of these three angles is equal to 90 degree, then root 2 cos pi by 4 minus A. I'll take the root 2 common from here. So pi by plus cos pi by 4 minus B plus root 2. Now open this one also. This is cos A minus B, which gives you cos A cos B minus sin A sin B. So this is cos x plus cos y, which is equal to root 2 cos A plus B upon 2 cos A minus B upon 2 plus now cos pi by 4 is equal to 1 by root 2 cos C minus 1 by root 2 sin C. Further, this is equal to root 2 cos pi by 4 pi by 2 minus A plus B whole divided by 2 cos these 2 will cancel and you will have B minus A upon 2 plus root 2. I'll take root 2 common, so take it outside. This is cos C minus sin C. Okay, sorry, here is a plus, not minus. Yeah, it's got to be plus, not minus. Okay. Now, this becomes equal to 2 root 2. So now this is equal to pi by 2 minus A plus B, that is equal to cos C by 2, correct? I'll take into this outside. And cos B minus A upon 2, I'll leave as such, plus cos C plus sin C. Cos C by 2, I'll leave it as such. So this is 2 root 2 cos C by 2 cos B minus A upon 2. Sorry, I was missing this plus 1, which was all over there. The plus 1 was there in the statement. So this plus 1 I missed. Okay. All right. So cos C by 2, this can be written as 2 cos square C by 2 minus 1. And this can be written as 2 sin C by 2 cos C by 2 plus 1. So these two are going to get cancelled and I will have cos C by 2 cos C by 2 common. You will be left with 2 root 2 cos B minus A upon 2 plus cos C by 2 plus sin C by 2, right? So further, this is equal to 2 cos C by 2 root 2 cos B minus A upon 2 plus, I'll take root 2 common and I'll multiply both the things with root 2, 1 by root 2. So this is equal to this. That is 2 cos c by 2 root 2 cos b minus a upon 2 plus root 2. This is equal to cos pi by 4 cos c by 2 sin pi by 4 sin c by 2. That becomes equal to 2. I'll take root 2 cos c by 2 cos b minus a upon 2 plus this is equal to cos pi, this cos pi by 4 minus c by 2, right? So now further, I'll take root 2 common and this will become 2 cos c by 2 into cos b minus a upon 2 plus cos. So now pi by 4 minus c by 2, this becomes, you know this thing, a plus b plus c is equal to pi by 2. That means c is equal to pi by 2 minus a plus b. So c by 2 will be pi by 4 minus a plus b by 2. Okay. Oh, sorry. This is also equal to, you can say, a plus b by 2 is equal to pi by 4 minus c by 2. So you can fill it at this place. So this will be a plus b upon 2. I hope you understood this step. So now further, root 2, it was already outside. This is equal to the cos pi by 2 now. This was actually common for the whole thing. Right? So this cos pi by 2 is common for this. Question number 23, it says if a plus b plus c is equal to pi by 2, then you have to find out the value of this given expression. Okay, so let's write it down. Root 2. I'll take root 2 common from these two first. Cos pi by 4 minus a plus cos pi by 4 minus b plus 2. So this is a minus b form, which gives me cos pi by 4, which is 1 by root 2, multiply cos c minus sin pi by 4, which is again equal to 1 by root 2 sin c. This is of the form cos x plus cos y. This is equal to root 2 cos x plus y upon 2 cos x minus y upon 2 plus root 2's will cancel and you will be left with cos c minus sin c over here. Sorry, it is plus c. Okay. So root 2, this is equal to pi 2 cos pi by 2 minus a plus b upon 2 cos b minus a upon 2 plus cos c. See, I was missing plus 1 over here, sorry. Right, plus cos c. And I can write down cos c as 2 cos square t c by 2 minus 1 plus this is equal to 2 sin c by 2 cos c by 2 plus 1. These two will cancel out. Here, root 2. Now this is pi by 2 minus a plus b whole upon 2. This is equal to 2 cos c by 2 cos b minus a upon 2 plus 2 cos square c by 2 plus 2 sin c by 2 cos c by 2. I'll take 2 cos c by 2 common. So I'll be left with root 2 into cos b minus a upon 2 plus cos c by 2 plus sin c by 2. Okay. So 2 cos c by 2. This is equal to, now further, okay, I'll do one thing. This is cos b minus a upon 2 plus, now I'll do one thing more time. I'll multiply the numerator and the denominator, like inside and outside the bracket with root 2. Cos c by 2 plus 1 by root 2 sin c by 2, which is 2 cos c by 2 root cos b minus a by 2 plus root 2. 1 by 2 is cos pi by 4, and see, cos pi by 4 is equal to sin pi by 4. Both are equal to 1 by root 2. So this is cos pi by 4 cos c by 2 plus sin pi by 4 sin c by 2, which is the formula for cos pi by 4 minus c by 2. Okay. This is cos c by 2 root 2 into cos b minus a upon 2 plus root 2. Now cos pi by 4 minus c by 2, when you will solve this thing, you already have a plus b plus c is equal to pi by 2. So pi by 4 minus c by 4 will give you cos of a plus b upon 2. Okay, right? Now I'll take root 2 also common outside. 2 root 2 cos c by 2. This is cos b minus a upon 2 cos a plus b upon 2. 2 root 2 cos c by 2 is, this is cos again x plus y form, which is 2 cos x plus y upon 2 cos x minus y upon 2, which is 2 root 2 cos c by 2. These 2 will cancel here and these 2 will cancel here. 2 cos 2b by 2 or 2 cos b. See, one thing more here, this was whole divided by 2 also. Okay, because this 2 was from here. Okay, right. So this is going to give you 2 cos b by 2, 2 cos minus a by 2, which is actually equal to a by 2 only, because cos of minus a is equal to cos a. You know that. So that is 4 root 2 cos a by 2, cos b by 2, and cos c by 2. This is the answer to the question. It was a very lengthy question actually. So what do you have in the answer, which is the correct option? I think it is A, right? Option A is the correct answer. Hope you understood this question. Then let's move to the next question, number 24. Sin hx is equal to tan A. You have to find out tan hx modulus is. Okay. So, you know, you are given that sin hx is equal to tan A, which means sin hx can be written as e raised to power x minus e raised to power minus x upon 2 is equal to tangent of A. Also, let's move to this. Tangent of hx is equal to sin hx cos hx, which is equal to half of, wait, Okay, this is equal to half e raised to power x minus e raised to power x upon 2 divided by half e raised to power x plus e raised to power minus x upon 2. So 2 will cancel in the numerator and the denominator. Okay, and now I want to have this numerator. See the sorry, denominator. This denominator is of the form e raised to power x plus e raised to power minus x. Somehow I want to get into this form, and this can be done. How? You can write it as mod of e raised to power x minus e raised to power minus x upon 2 whole divided by. So this can be written as e raised to power x minus e raised to power minus x upon 2 whole square plus 1. Okay, these two will have the same meaning, will have the same output. So now this further, this is equal to tan A and this is equal to tan A, which gives you mod of tan A upon root of tan square A plus 1. Okay. And one more identity, 1 plus tan square A is equal to secant square A. This gives you tan A upon secant A. Okay. So that's equal to actually sin A. So we have option A as the correct answer. Hope you understood this. Then let's move to the next question, number 25. It says sin h x plus y plus sin h x minus y upon cos h x plus y minus cos h x minus y is equal to. These formulas, I think sin h x plus y. This can be, I'll directly write it down. So this can be written as 1 by 2 for the numerator, 1 by 2 e raised to power x plus y minus e raised to power x minus y plus 1 by 2 e raised to power x minus y minus e raised to power minus x plus y. This whole is divided by 1 by 2 e raised to power x plus y plus e raised to power x minus y plus half e raised to power x minus y plus e raised to power minus x plus y. So half will cancel all the way from the numerator and the denominator. You will be left with e raised to power x plus y plus e raised to power x minus y. So I'm combining these two terms minus e raised to power minus x minus y plus e raised to power minus x plus y whole divided by, sorry, e raised to power x plus y e raised to power x minus y plus e raised to power minus x minus y minus e raised to power minus x plus y. This is gonna give me e raised to power x minus e raised to power minus x minus e raised to power minus x upon e raised to power y plus e raised to power minus y whole divided by e raised to power x minus e raised to power minus x e raised to power y minus e raised to power minus y. I hope you're already aware, like, how did I come to this step? Let's explain it further over here. So e raised to power x plus y. Question number 25, sin h x plus y plus sin h x minus y upon cos h x plus y minus cos h x minus y is equal to. You know the formula for this, sin h x plus y. I can open it directly. This can be written as half into e raised to power x plus y minus e raised to power minus x minus y plus 1 by 2 e raised to power x minus y minus e raised to power minus x minus y plus y whole divided by half e raised to power x plus y plus e raised to power minus x minus y plus 1 by 2 e raised to power x minus y plus e raised to power minus x plus y. Half will cancel from the numerator and the denominator, and I'll be left with e raised to power x plus y plus e raised to power x minus y minus e raised to power minus x minus y plus e raised to power minus x plus y upon this sorry okay here will be minus e raised to power x plus y minus e raised to power x minus y plus e raised to power minus x minus y e raised to power minus x minus y minus e raised to power minus x plus y. Now let's open it. You will have e raised to power x into e raised to power y plus e raised to power x into e raised to power minus y minus e raised to power minus x into e raised to power minus y e raised to power minus x into e raised to power y whole divided by e raised to power x e raised to power y minus e raised to power x e raised to power minus y plus e raised to power minus x e raised to power minus y minus e raised to power minus x multiply e raised to power y. Okay, so here I'll take e raised to power x common, e raised to power y plus e raised to power minus y minus e raised to power minus x common, e raised to power y plus e raised to power minus y whole divided by e raised to power x will be taken common, e raised to power y minus e raised to power minus y plus e raised to power minus x e raised to power this I can say minus y upon e raised to power minus e raised to power y. Okay, I'll take the factors e raised to power x minus e raised to power minus x is in product with e raised to power y plus e raised to power minus y whole divided by, see, to make them equal, I'll take it outside. So it will be e raised to power x minus e raised to power minus x, e raised to power y minus e raised to power minus y. These two are going to get cancelled and I'll be left with e raised to power 5 minus plus e raised to power minus y divided by e raised to power y minus e raised to power minus y. Now let's divide the numerator and the denominator by 2. This is the formula for cos hy upon this is the formula for sin hy, which is equal to cot hy. So this is the answer to our question. Option B is the correct answer. Hope you understood. Let's move to the next question, number 26. It says if A, B, C are the sides of the triangle ABC and this determinant is equal to 0, then you have to find out the value of this expression. Okay, right. So let's write it. Determinant form B1A, A1C, C1B is equal to 0. Let's find out the determinant. You will have B minus C minus 1, AB minus C square plus A minus C is equal to 0. B square minus BC minus AC plus C square plus A square minus AC is equal to 0. So let's combine the squares. A square plus B square plus C square minus AB minus this minus AC is equal to 0. Now this is actually, this is the formula for A minus B whole square plus B minus C whole square, C minus A whole square, right? So in order to be this to be equal to 0, because they all are squares, that means, of course, this should be equal to 0. A minus B should be equal to 0. B minus C equal to 0. And C minus A also should be equal to 0. From here, I get A is equal to B is equal to C, and C is equal to A. So that means all the three are equal. All the three are equal, which means this is an equilateral triangle, right? So equilateral triangle, that means I have all the angles equal to 60 degree. That, okay, we have to find out this. All the angles are 60 degree. That simply means angle A is equal to B is equal to C. That is equal to 60 degree. Cos 60, 2 plus cos 60, cos 60 is equal to 2 into 3 into cos 60. So 2 into 3 into cos 60 degree is equal to 1 by 2. That means I have 3 as the answer. Option C is the correct answer. Hope you understood this question. Then let's move to the next question. Question number 27. In a triangle ABC, if A is pi by 3 and B is pi by 4, then you have to find out the value of A square minus B square upon C square. So here, in a triangle, A plus B plus C is equal to pi. That gives angle C is equal to pi minus pi by 3 minus pi by 4. That gives you pi minus 7 pi by 12, or that's equal to 5 pi by 12. That is C, right? Now, using the sine rule, you have A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to some constant K, right? First of all, I have this is A upon sine pi by 3. That's equal to B upon sine pi by 4. I know both the values, but the problem is I have to find out what will be sine 5 pi by 12. Let's solve it here. Sine pi by 12, 5 pi by 12. This can be written as sine pi by 4 plus pi by 6. This is sine A plus B. That's equal to sine A, sine B. Sorry, sine A cos B plus cos A sine B. Sine pi by 4 is 1 by root 2 and sine pi by 6 is root 3 by 2 plus 1 by root 2 into 2. That gives you, this is root 3 upon this plus 1 upon 2 root 2, which is equal to root 3 plus 1 to root 2. So now let's use this thing to fill over here. You have A upon sine pi by 3, that is equal to A upon root 3 by 2, that's equal to B upon 1 by root 2, and that's equal to C upon root 3 plus 1 upon 2 root 2, that is equal to some constant K, right? So solving it further, here A is equal to root 3 by 2 into K, B is equal to K upon root 2, and C is root 3 plus 1 upon 2 root 2 whole multiplied by K. You have to find out the value of A square minus B square upon C square. Let's go for this. To find A square minus B square upon C square, that's equal to root 3 upon 2, which is 3 by 4 K square minus K square by 2 whole divided by, that's equal to root 3 plus 1 upon 2 root 2 square into K square. So these K squares will cancel out, and you will have 3 by 4 minus 1 by 2 upon 3 plus 1 plus 2 root 3 whole divided by 2 root 2. That means it's multiplied by 4 into 2, 8. Okay, so that's gonna give you So this is equal to 3 minus 2. So this is 1 by 2, 1 by 4. 1 by 4 into 8 upon 4 plus 2 root 3. That's gonna give you 2. So 2 upon 2, I'll take common, 2 plus root 3, which is going to give me 1 plus 1 upon 2 plus root 3. So looking at that, 1 plus 2 root 1 upon 1 plus, sorry for this, 1 upon 2 plus root 3. This is not in the option. So I'll rationalize the denominator further. 1 upon 2 plus root 3 minus multiply 2 minus root 3 upon 2 minus root 3, which is gonna give me 2 minus root 3 upon a square minus b square, that is 2 minus root 3 is the answer, which is option A. So this is the answer to this question. Hope you understood this. Let's move to the next question. Question number 28. In a triangle ABC, if A is 3, B is 7, C is 8, then you have to find out the value of this expression. Okay, so you are given A, B, and C. You know one thing, the semi-perimeter is given by A plus B plus C upon 2, 3 plus 7 plus 8 upon 2, that's 18 upon 2, or that's equal to 9. Now, you have this, we have to find out sine B by 2 tangent of C minus A upon 2. Now, what is the value of tangent of, see, sine B by 2, that's easy to go with. I can find out sine B by 2 easily, but I have to solve for this thing. So let's go for this first. Tangent of C minus A upon 2. By using the sine rule, you have A upon sine A is equal to B upon sine B is equal to C upon sine C is equal to some constant K. That means A is equal to K sine A, B is K sine B, and C is K sine C. C is K sine C. Right. Now, C minus A, if I take C minus A upon C plus A, that will be K sine C minus K sine A upon K sine C plus K sine A. Right? KK will cancel in the numerator and denominator. You will be left with sine C minus sine A upon sine C plus sine A. This is what I'm solving for, tan C minus A upon 2. Correct? Now let's expand. This is sine C minus sine A. This will be written as 2 cos C plus A upon 2 sine C minus A upon 2, 2 sine C plus A upon 2 cos C minus A upon 2. 2 and 2 will cancel from the numerator and the denominator, and this will be cotangent of C plus A upon 2 and 2 tangent of C minus A upon 2. Right? So see, cotangent of C plus A plus B plus C is equal to pi by 2. Pi. Right? That means A plus C is pi minus B. Why? You can write it as cot pi minus B upon 2 into tangent of C minus A upon 2. This is equal to cotangent of pi by 2 minus B by 2 into tangent of this. So that's equal to cotangent pi by 2. This will change into tangent. So this is tangent B by 2 multiply tangent C minus A upon 2. right? So we were solving it for tan c minus a upon 2. The value comes out to be equal to tangent of b by 2 multiplied by tangent of c minus a upon 2. Correct? Now let's get back to our problem. We were over here. Let's start solving it further. So this can be written as sin b by 2 multiplied by c minus a upon c plus a into cotangent of b by 2. Right? I hope you got this thing, right? This was equal to c minus a upon c plus a. So c minus a upon c plus a into 1 upon tangent of b by 2 is equal to tangent of c minus a upon 2, right? You will take it in the numerator and this will change into cotangent of b minus 2, b upon 2, right? So now I'm over here sin b by 2 into sin cotangent c minus a upon c plus a into cotangent b by 2. So this is equal to c minus a upon c plus a into sin b by 2 into cos b by 2 upon sin b by 2. So these will cancel out and you will have c minus a upon c plus a into cos of b by 2, right? Cos of b by 2 can be written as s minus p upon ac. So c was equal to 8. It's given in the question. A is 3. So 8 minus 3 upon 8 plus 3. S we calculated. It was 9. 9 minus 7 upon 3 multiply 8. That is equal to 5 upon 11 multiply. This is 3 into root 2 upon. This is root 3 into 2 root 2. So these will cancel out. Correct? And you will have 5 root 3 upon 22 as the answer to the question. Hope you understood this. Let's check. We have option D as the answer. Hope you understood this question. So let's move to the next question then. Question number 29. Question number 29. Let A, B, C be the triangle and A, B, C be the position vectors of A, B, and C respectively. If D divides BC in the ratio 2:3 internally and E divides C in the ratio 2:1 internally, then the position vector of the point P, which divides DE in the ratio 3:5 internally, is. Let's make the figure first for this problem. Let's make the triangle ABC. Let's say this is the triangle. So if I'm taking this as A, B, and C, it is saying you D divides BC in the ratio 2:3. So if I'm taking this as D, right? Okay, one thing more, it is said that A, B, C are the position vectors. So position vector for A is given by this, B is given by this, C is given by this. This is capital C. Okay, right. Now D divides the line BC in the ratio 2:3. So if I'm taking this as 2, this is 3. This is the division of D. And let this be the vector. Okay. And E divides CA in the ratio 2:1. So here is some E. It divides CA in the ratio CA in the ratio 2:1. So this is 2 and this is 1. And this is point E. And let this be the vector E. Now, internally, then the position vector of the point P, which divides DE in the ratio. So now let's combine DE. Okay, so this is the point E if I'm taking. There is a point P, which divides DE in the ratio 3:5. DE, so this is 3 and this is 5. Okay, and this is the position vector for P. You had to find out, what we had to find out in the question is, okay, position vector of the point P. This is what you need to find out. Position vector of the point P, which divides DE in the ratio 3:5. All right. Okay. Let's find out. First of all, to find for P, you need the coordinates of position vector coordinates for D and E. Okay. So the point D can have the coordinates as D will be given by okay. So D is equal to 2 into C vector. D vector is equal to 2 into C. I'll just write down as such only. 2C plus 3B upon 2 plus 3, that is equal to 5. Similarly, E is equal to 1 into C plus 2 into A upon 1 plus 2, that is equal to 3. Right? This is the position, this is E and D and E respectively. Now the P vector will be given by 3 into E, that is equal to C plus 2A upon 3 plus 5 into D, that is equal to 2C plus 3B upon 5. They will cancel out each other and you will have C plus 2A plus 2C plus 3B, which will give me 3C plus 2A plus 3B. Okay, one thing I forgot over here, this whole will be divided by 5 plus 3, that is 8. Okay, so 3C plus 2A plus 3B whole divided by 8 is the answer to the question. That is option A. Hope you got that. Let's move to the next question then. Question number 30. If 2I plus 4J minus 5K and this, these are the position vectors for A, B, and C vertices of a triangle respectively, then the unit vector along the median drawn through the vertex A is, let's try and make the figure first for the problem. If this is the triangle, this is A is given by the vector 2I plus 4J minus 5K. B is given by the vector I plus J plus K. And there is a C vertex which is given by the vector J plus 2K. Now it says there is a median through the vertex A. So let's draw this median. This is M. You know the median divides the line in the ratio 1:1. So first of all, to answer the question, let's first of all find out the midpoint M of this. So the position vector of this point M is M position vector will be equal to I plus 0, that's I, J plus J, that's 2J, and K plus 2K is equal to 3K whole divided by 2 because M is the median. Sorry. Now the median drawn through the vertex A is MA, right? Median drawn through the vertex A is given by MA. Median through vertex A is MA, which will be given by A minus M. Actually, A is 2I plus 4J minus 5K minus, and M is I plus 2J plus 3K whole divided by 12. Correct? So let's solve it. You'll have 4I and this is plus 8J minus 10K minus I minus 2J minus 3K whole divided by 2. That is 3I plus 6J minus 13K whole divided by 2. Right? This is the median through the vertex A position vector. This is MA. Okay. Now, vector through the median drawn through vertex A is given by vector along the median drawn through the vertex A is given by MA upon the modulus of it. So this MA was equal to 3I plus 6J minus 13K whole divided by 2 upon the mod of it. You know, the mod is given by root of, this is 3 square is 9, 6 square is 36, 13 square is 169 upon 4. Okay. So this is going to give me, let's solve it further. This is 3I plus 6J minus 13K upon 2. So 2 and this 2, actually this root 4 and this 2 will get cancelled. Okay. Multiplied by root of 9 plus this is gonna give me 214. Okay, and this will cancel. You'll be left with 3I plus 6J upon root of 214. Now let's check with the options. We have here option B as the answer to the question. Hope you understood this. Then let's move to the next question, number 31. Let L be a line passing through the points 2I plus 3J plus 8K and this vector. Let P be the plane passing through this vector and parallel to these two vectors. If L meets the plane P at the point A, then the position vector of A is. All right. So first of all, you are given that the line let L be the line which is passing through these 2 points. So the general, first of all, vector which is passing through these 2 points is given by R is equal to 2I plus 3J plus 8K plus lambda 2I plus 3J plus 8K minus I minus 6J minus 4K. That gives you 2I plus 3J plus 8K. So this will be plus lambda into I cap minus 3J cap plus 4K cap. Right, this is the vector for this line which is passing through these 2 points. And what will be the equation of the line? Equation of line L passing through these 2 points or these 2 vectors will be given by L is that x minus 2 upon 1 is equal to y minus 3 upon minus 3 is equal to z minus 8 upon 4. This is equal to some lambda, let's say. Now, next thing it's given, let P be the plane passing through this and parallel to these 2 vectors. Now, the plane is parallel to these 2 vectors. Now, plane is parallel to I minus j plus k and I minus 2j plus 3k. Using that, this vector will be given by 1 minus 1, 1, 1 minus 2 and 3. So this is equal to I cap minus 3 plus 2 minus j 3 minus 1 and plus k minus 2 plus 1. That will be minus I minus 2j and minus k. This is the position vector. Now, you are also given that this, let P be the plane passing through this point. Equation of the plane. So, equation of the plane passing through the point minus 5I plus 19j minus 14k. See, if this is the line, plane, sorry, if this is the plane, then Let this be the point of intersection of the plane and the line A. Okay. Now equation of the plane which is passing through this point will be given by, general equation is A into x minus x1 plus B y minus y1 C z minus z1 is equal to 0. That gives you minus 1 x plus 5 minus 2 y minus 19 minus 1 z plus 14 is equal to 0. So this will give me minus 5x, minus x minus 5 minus 2y plus 38 minus z minus 14 is equal to 0, or this will be minus x minus 2y minus z. This is going to give me, wait, this is 19 and plus 19 is equal to 0. Or this will give me x plus 2y plus z is equal to 19. Right? This is the equation of the plane P. Now, any general point on this line, any general point on this line we talked about here, point on the line x minus, it was x minus 2 upon 1 is equal to y minus 3 upon minus 3 is equal to z minus 8 upon 4 is equal to k. Any general point will be given by x is equal to k plus 2. That was lambda. X is equal to lambda plus 2, y is equal to minus 3 lambda plus 3, z is equal to 4 lambda plus 8. So, A point has the coordinates as lambda plus 2, minus 3 lambda plus 3, and 4 lambda plus 8. Okay, so over here we just, at the point of intersection. Now, now this plane point lies on the plane, correct? So let's fill in this equation. In equation 1. So this will become, the equation was x plus 2y plus z is equal to 19. So this will be lambda plus 2 into minus 3 lambda plus 3 plus 4 lambda plus 8 is equal to 19, which will give me lambda plus 2 minus 6 lambda plus 6 plus 4 lambda plus 8 is equal to 19 minus lambda. This is 8 and this is going to be 16. So this is equal to 3, which gives you lambda is equal to minus 3. So now the point of intersection, it was lambda plus 2 minus 3 lambda plus 3, 4 lambda plus 8. Now the point of intersection will be minus 1, 12 and 4, minus 4. Okay, this is the point of intersection. So according to the point of intersection, what will be the position vector for A? This will be given by minus I cap plus 12j cap minus 4k cap. This is the answer to our question. Let's check with the options. Minus I plus 12j minus 4k. This is option B. So we have option B as the answer. Hope you got that. Let's move to the next question, number 32. Let A, B, C be 3 unit vectors satisfying this equation. Then the statement 1, this. Statement 2 is this. Which of the above statements is true? Okay, let's pick up the situation first. You are given A, B, C are 3 unit vectors. That means the mod is 1. For this, mod of B is 1. and this is also 1. Okay, all of them are 1s, and a minus b square, a vector minus b vector square plus a vector minus c vector square is equal to 0. This can be written as a vector square plus b vector square minus 2a into b dot b, right? Plus a vector, sorry, a mod b mod square, and here is minus 2a c. Now this is equal to 10, not 0. Okay, now this is equal to 1 plus 1 minus 2a dot b plus 1 plus 1 minus 2a dot c is equal to this. This gives you a dot, I'll take it this side, minus 2. This is equal to 6, or a dot b plus a dot c, this is equal to minus 3. Okay, now pick up the first statement. It says you this thing, let's write it down. From the first statement, let's write it down. You have a plus 2b square plus 2a plus c square. So this will be a square plus 2b. I'll take 2 outside. So this will be 4. B square plus 4a dot b, 4a square plus c square plus 4 a dot c. This is equal to, okay, what was that? That's equal to 2. It should be equal to 2. So let's solve it, if whether it comes out to be equal to 2 or not. That makes you 1 plus 4 plus 4 a dot b plus 4 plus 1 4 a dot c. That's 10 plus 4. This, and we just solved, this is equal to minus 3. So that becomes 4 plus 10 plus 4 into minus 3, which is equal to minus 2. But we are given that this is equal to 2. 2 is not equal to minus 2. So that means statement 1 is wrong. Now go for the second one. This one, let's write it down. So this is 2a plus 3b square, 3a plus 2c square. That makes 4a square, 9b square plus 12a dot b plus 9a square, 4c square, 6a dot c. That's equal to what? We'll find out. So this is 4 plus 9 plus 9 plus 4 plus 12. Oh, sorry, this is supposed to be 12 over here. A dot b plus a dot c is equal to question mark. And this is 18 plus 8, that's 26 plus 2 into minus 3. So 26 minus 36, this is equal to minus 10. But we are given that this is equal to 10. That means the statement 2 is also wrong. This is not equal to 10. So we have both the statement 1 and 2. They are false. That is option D is the correct answer. Hope you understood. Next is question number 33. Now again a vector problem. It says if r dot this vector is 5 and r dot this vector is 7, they are the two planes and this is a point common to both the planes. Then the vector equation of the line of intersection of the plane is r is equal to what? All right. So you are given first thing. Let's write down. P1 is such that r dot 2i 3j 4k is equal to 5. and the second plane represented by R into I plus J minus K is equal to 7. Now, all right. So now let N1 is equal to, let's say this is equal to N1 and this is equal to N2. Okay. So these are the two planes such that is the point common to both the planes. Therefore, N can be represented by the cross product of N1 and N2. So N will be given by I, J, K, 2, 3, 4, 1, 1, minus 1. So this will give you I minus 3, minus 4, minus J minus 2, minus 4, plus K 2, minus 3. This will give me minus I cap plus 6 J cap minus K cap. Okay. Now, equation of the line of intersection of planes passing through this point. Equation of the line of intersection of planes passing through the point 16 minus 9 and 0. This will be R is equal to 16I minus 9J plus 0K, or I'll just, okay, just let's write on this. Plus lambda into minus 7I plus 6J minus K. So this is 16 minus 7 lambda I cap plus 6 lambda minus 9 J cap minus lambda K cap. This is the required equation, and we have 16 minus 7 lambda I cap, and okay, 16 minus 7 lambda is only present in option B, and this is the answer. Hope you understood this. Let's move to the next question, number 34. Let ABC be a triangle. Let P be the point which divide AB in the ratio 1:2 internally. Okay, let's make the figure by the side. So you are given that this is a triangle A, B, and C. P be the point which divide AB in the ratio 1:2 internally. So let this be the point P. This is dividing the line AB in the ratio 1:2 internally. And point Q divide BC in the ratio 1:2. So let it be here somewhere 1:2. Let Q be the point. Let D be the point of intersection of AQ and CP. So AQ and CP, let's join them. So this is given that this point of intersection of both of them is Q. Sorry, it's T. Correct. Okay. If the area of the triangle ABC, area triangle ABC is K square units, then the area of triangle BCD. This is what you had to find out. Okay. So, all right. We are given number of things. Let's start with the solution now. First thing, I'm assuming the points of AB, A to B, A, B, C be the triangle. Okay. So let's say AB is this. This is having coordinates as AB. B has the coordinates as 0, 0. That is the origin. See, I'm shifting the whole triangle to the origin. Like B will be coinciding with the origin. So let the coordinates of B be 0, 0. A will have the coordinates as C0. Sorry, AB. And C will have definitely the coordinates as C0 then. Okay. Right. So that's it. Now, Let's find out the coordinates for P. Now, P is dividing the line AB in the ratio 1:2. So, the coordinates of P will be given by 0 plus 2A upon 2, 2 plus 1, 3. And this will be 0 plus, this is 0 plus 2B upon 2 plus 1. So this will be equal to 2A upon 3 and 2B upon 3. These are the coordinates of the point P, right? The next one for the Q. Let's find out the coordinates for the point Q. Now Q is dividing the line BC in the ratio 1:2. So the coordinates of B will be given by C plus 0 upon 2 plus 1, that is 3. And this is, and the next one is 0 plus 0 upon 2 plus 1, 3. So the coordinates of Q will be given by C upon 3, comma 0. Now let's say the point D is dividing the line AQ in the ratio lambda 2:1. Okay. Now if D is dividing the line AQ in the ratio lambda 2:1, the coordinates of D, let's find out. Okay, let's go for only the Y coordinate. It's okay. The coordinates of D will be given by, just a minute. Okay, so this is equal to lambda 2 into C upon 3 plus A upon lambda 2 plus 1. And the Y coordinate will be given by 0 plus B upon lambda 2 plus 1. So these are the coordinates. Let's write down lambda 2 into C upon 3 plus 8 whole divided by lambda 2 plus 1, comma B upon lambda 2 plus 1. These are the X and Y coordinates for the point D. Now, also let's say that D divides PC in the ratio lambda 1:1. Okay, so let's say D divides PC in the ratio lambda 1:1. Therefore, the Y coordinate. See, I'm not interested actually in the X coordinate, so I'll directly go with the Y coordinate. Y. X coordinate is becoming like it's having very much variables, whereas Y is simpler. So I'll pick up that one to solve the question. Y coordinate of D will be given by, according to this, the Y coordinate of D will be given by lambda 1 into 0 plus 1 into 2B upon 3 whole divided by lambda 1 plus 1. So this is equal to 2B upon 3 into lambda 1 plus 1. This is the Y coordinate of D. So according to that, see, this is also the Y coordinate of D and this is also the Y coordinate of D. That means both are equal. That means B upon lambda 2 plus 1 is equal to 2B upon 3 lambda 1 plus 1. So B and B will cancel. You have 3 lambda 1 plus 3 is equal to 2 lambda 2 plus 2. So 3 lambda 1 minus 2 lambda 2 plus 1 is equal to 0. Right. Now, let's see the X coordinate over here. I'll pick up that also. This is the X coordinate. This was the X coordinate, this one. So, also, let's find out the X coordinate for this also. This was the Y coordinate. X coordinate. Question number 34. Let ABC be a triangle. Let the point P divide AB in the ratio 1:2 internally. And then let point Q divide BC in this ratio internally. Let's make the figure to have a clear picture of the problem. So this is the triangle ABC. And now it's given that P divides AB in the ratio 1:2. So this is 1:2. Similarly, Q divides BC in the ratio 1:2. All right. Now it is given that D is the point of intersection of AQ and CP. So this is the point of intersection D. If the area of the triangle ABC is K square units, then the area of the triangle BCD, that's BCD, this triangle. This triangle is given by. So first of all, I'll assume the B is lying at the origin. If B is lying at the origin, the coordinates of C will be given by C comma 0. And let the coordinates of A be AB. So these are the three coordinates. B is at origin and C is at 0. Now you are given that P is dividing line AB in the ratio 1:2. Applying the section formula, we can find out the coordinates of P and Q using section formula. P will be given by 1 into 0 plus 2 into A upon 1 plus 2, that is 2A upon 3. Similarly, the Y coordinate will be given by 1 into 0 plus 2 into B upon 1 plus 2, so that is equal to 2B upon 3 as well. Similarly, Q will be given by 1 into 0 plus 0 into 0, 1 into C upon 3 plus 0 actually. So this is equal to the Y coordinate is 0 plus 0 upon 3. That means Q will have the coordinates as C by 3 comma 0. These are the coordinates of Q. Now you are given that D is dividing the line AQ. D is the point of intersection. So let the point of intersection, this is lambda 1 into 1. D is dividing CP in the ratio lambda 1 is to 1 and AQ in the ratio lambda 2 is to 1. Let D divides AQ in the ratio lambda 2 is to 1. Then the Y coordinate of D will be given by B upon lambda 2 plus 1. Similarly, D is also dividing CP in the ratio lambda 1 is to 1. Therefore, the Y coordinate of D will be given by 2B. I'm applying the same section formula. So I'm considering only the Y coordinate of D. This is equal to 2B upon 3 into lambda 1 plus 1. So both are the Y coordinates of D. That means both of them are equal. That means B upon lambda 2 plus 1 is equal to 2B upon 3 lambda plus 1. B and B will get cancelled. You will have 3 lambda 1 plus 3 is equal to 2 lambda 2 plus 2. Or 3 lambda 1 minus 2 lambda 2 plus 1 is equal to 0. Similarly, since the Y coordinates were equal and the X coordinates will also be equal. X coordinates of D will also be equal. And applying the same section formula, you will calculate the coordinates of X coordinate of D. This will be 2A upon 3 plus lambda 1 C whole divided by lambda 1 plus 1. This is equal to A plus lambda 2 into C by 3 divided by lambda 2 plus 1. This gives you C is equal to 2 by 3 lambda 2 into 3 upon 3 plus A to A upon 3 plus lambda 1, which on solving will give you lambda 1 is equal to 2 by 9 lambda 2. Let's put this one in equation this. Let's name it as 1. So filling this one in equation 1, you will get the equation 1 was 3 lambda 1 minus 2 lambda 2 plus 1 is equal to 0. 3 lambda 1 minus 2 into 2, that is equal to 4 upon, this one will be 2 lambda 2 upon 9 multiplied by 3 minus 2 lambda 2 plus 1 is equal to 0, which will give you 2 lambda 2 upon 3 minus 2 lambda 2 plus 1 is equal to 0, or minus 4 lambda 2 upon 3 is equal to -1, which gives you lambda 2 is equal to 3 by 4. And you will solve to get lambda 1 is equal to 1 by 6. Now you are given the area of the triangle ABC and you have to find out for the BCD. You know one thing, area of triangle ABC upon area of triangle BCD, right? You know, half into base, ABC's base is BC and height is B. Half into BCD base is again BC and height is the Y coordinate of C. This is the Y coordinate of A and this is the Y coordinate of D. What is the Y coordinate of D? I'll take the simpler one. The Y coordinate of D we calculated was this. I'll take the simpler one. You can take this one also, but of course, I'll go with this one. B upon lambda 2 plus 1. B upon lambda 2 plus 1. So they will cancel out and you will have lambda 2 plus 1. Lambda 2 was equal to 3 by 4 plus 1, that is equal to 7 by 4. Now area of triangle ABC was K. You have to find out area of triangle BCD. That is equal to 7 by 4. So area of triangle BCD is equal to 4 by 7 into K. This is the answer to the question, right? That means we have 4 by 7K. We have option A as the answer to this question. Hope you understood this. Then let's move to the next question. Question number 35. If 10 is the mean deviation of n observations, that x1, 2, 3, 4 till n, then the mean deviation of the observations, these is, actually this is pretty easy. You just need one formula for that. You are given that the mean deviation of n observations, x1, x2, let's write down, mean deviation of x1, 2, x3 till xn is 10. Now we know that if the mean deviation of ax1 plus b, ax2 plus b till axn plus b is a times mean deviation of x1, x2, x3 till xn. Therefore, mean deviation of, you have to find out this, is 2x1 plus 5 upon 3, 2x2 plus 5 upon 3, 2x3 plus 5 upon 3 till 2xn plus 5 upon 3. So this can be written as 2 upon 3 x1 plus 5 upon 3, 2 upon 3 x 2 plus 5 upon 3, so on till 2 upon 3 xn plus 5 upon 3. So here A is 2 by 3. And B is 5 by 3, correct? Therefore, this expression is, the mean deviation of this is 2 by 3 into mean deviation of x1, x2 till xn. That was given to you as 10. So the answer is 20 upon 3. That means we have option C as the answer to this question. Hope you understood. Next is question number 36. A bag contains 9 identical black balls numbered from 1 to 9. So you have black balls numbered from 1 to 9 and 4 identical white balls numbered from 1 to 4. White balls numbered from 1 to 4. Now this bag, they are contained in a bag. These are black and white. Now 3 balls are drawn at time randomly from that bag and the probability of getting at least 1 white ball is. So 3 balls are drawn. You have to find out the probability of at least one white ball. That will be given by probability of like one white ball and two black balls are drawn, plus the probability two white and one black ball is drawn, plus the probability that all the three balls which are drawn are white and zero black balls are drawn. Now, this can be written as 1 white. So this is 4C1 out of 9. You can choose 2 plus 4C2 into 9C1, 4C3 into 9C0. This whole is divided by, there are 9 plus 44, that is equal to 13 balls. So this is divided by 13C13. 4C1, this is 4, 9C2 is 9 factorial upon 7 factorial into 2 factorial, plus 4C2 is 4 factorial upon 2 factorial upon 2 factorial into 9 upon 8 into 1 plus 4C1, that's equal to 4 again, and 9C0, this is equal to 9. Okay. So, there's a correction. Here was 3 because 3 balls were drawn, and this is 4 multiplied by 1. Right? 9C0 is equal to 1. This whole is divided by 13C3. So, this is 13 factorial upon 10 factorial into 3 factorial. Let's go for the multiplication. You have this as 4 into 9 into 8 divided by 2 will give you 36. Plus this will be 4 into 3 divided by 2, that's 6. Multiply by 9 plus 4 whole divided by, this will be 13 into, let's write down 13 into 12 into 11 upon 3 into 2, which is 6. So this will cancel out at 2. This will give you 14 6 are, 36 4s are, it's going to give you 144 plus 54 plus 4, that's for 58. And this is divided by 13 multiplied by 2 multiplied by 11. Now adding both of them, you will have 1. This is 2, 0, 2 divided by this. So this is going to give you 101 divided by 143. So this is answer to the question. Let's check with the options. 101 divided by 143 is option A. Hope you understood this. Next is question number 37. Probabilities of two people to hit a target are 1 by 4 and 1 by 5 respectively. The probability that the target is being hit when both of them attempt independently is. All right. So first you are given probability of A to hit the target is 1 by 4. That means probability of A not to hit the target, this will be 3 by 4. You know this, that's their sum is always equal to 1. So probability of not hitting the target by A is 3 by 4. Probability of B to hit the target 1 by 5. Similarly, probability for B to not hit the target will be given by 4 by 5. The logic is same. The sum of the two is equal to 1. Okay. All right. So now the probability that the target is being hit when both of them attempt independently is required probability is PA B dash plus PA dash in dot PB plus PA into PB. So this is equal to 1 by 4 into 4 by 5 plus 3 by 4 into 1 by 5, 1 by 4 into 1 by 5. That's going to give you 1 by 5 plus 3 by 20, 1 by 20. So this is going to give me 8 by 20 or 2 by 5. So the answer to the question is 2 by 5. That is option C. Hope you got that. Next is question number 38. When 3 dice are thrown at a time, the sum of the numbers appeared on 3 dice was found to be 15. Okay, then the probability that the number 5 does not appear on any one of the dice. To answer the question, first of all, let's write down all the cases when you will throw 3 dice and get the sum as 15. Okay, now you have 3 dice thrown. Let A be the case when sum of number appeared is equal to 15. Those are 6, 6, 3, 6, 3, 6, 3, 6, 6, 6, 5, 4, 6, 4, 5, 4, 6, 5, 5, 6, 4, 4, 5, 6, 5, 4, 6, and 5, 5, 5. Right now, probability that number 5 does not appear or any one of the dice. How many are the cases when number 5 does not appear? Only these 3 are the cases when number 5 is not appearing, right? So let B be the event in which number 5 does not appear on any dice. So those cases are 6, 6, 3, 6, 3, 6, and 3, 6, 6. These are the 3 cases. Now the required probability of event B upon A is given by number of times A intersection B upon number of the event A, number of the cases in the event A. So this is 3, 1, 2, 3, 3 upon, these are 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. So the answer to the question is 3 by 10 and option B is the answer. Hope you understood this. Next is question number 39. The probability distribution of a random variable x is given by this. Then the mean of x is. All right. See, this is a probability distribution question. You know one thing, that the sum of total probability is always 1. Right? Therefore, according to the question, this plus this plus this whole things is equal to 1. 0 plus k plus 2k plus 5k square plus 2k square plus 3k is equal to 1. That's 7k square, 2 and okay, plus 6k minus 1 is equal to 0. Now let's factorize this. You will have 7k. This is 6k. No, sorry, this is 7k only. 7k minus k minus 1. So I'll take 7k common, k plus 1 minus 1 common, k plus 1. The two factors are 7k minus 1 and k plus 1 is equal to 0, which gives you k is equal to 1 by 7 or minus 1. Minus 1 value of k is not possible. The probability can't be negative. So that means k is equal to 1 by 7. Now, you are given that you have to find out the mean of x. Mean of x will be, see, this is 0 multiplied by 0 plus 2 multiplied by k plus 4 multiplied by 2k plus 6 multiplied by 5k square plus 8 multiplied 2k square plus 10 multiplied 3k. So this is equal to 0 plus 2k plus 8k plus 30k square plus 16k square plus 30k. So this is equal to 40k plus 46k square. I have the k value as 1 by 7. So 40 upon 7 plus 46 into 1 upon 49. So this is equal to, let's take the LCM. 49. So 280 plus 46. This is equal to 326 upon 49. This is the answer. 326 upon 49 is option D. Hope you understood this. Let's move to the next question, number 40. The probability of getting a success in a trial is 5 times that of a failure. The probability of getting at most one success in 5 trials. Okay, so there is a success and failure thing over here. Let the probability of success be P. And that of failure is equal to Q. You are given the probability of success is 5 times the probability of the failure. Also, you have P plus Q is equal to 1. So, P plus Q is equal to 1. That means 5Q plus Q, which gives you 6Q is equal to 1, or Q is 1 by 6 and P is equal to 5 by 6. Correct? Now, probability of at most one success. That means you have to find out the probability of getting maximum one success. Less is also possible. So, probability of at most one success is the probability of having 0 success plus the probability of one success. Probability of 0 success is 5C0, P raised to power 0, Q raised to power 5, because 5 trials are there, correct? Plus 5C1, P raised to power 1, Q raised to power 4. This will give you 5C0 is 1, P raised to power 0, that's 5 by 6 raised to power 0, and thing raised to power 0 is equal to 1. Q is 1 by 6, so 1 by 6 raised to power 5 plus 5 multiply 5 by 6 multiply 1 by 6 raised to the power 4. Okay, let's solve it further. So I'll take 1 by 6 raised to power 4 outside. I'll be left with 1 by 6 plus here is 25 by 6. So 1 by 6 raised to power 4 multiply 26 upon 6, which will give you 26 upon 6 raised to 5 raised to power 5 as the answer. So that is option A. Hope you understood this question. Next is question number 41. B, C, D. These are 3 points. If A is a variable point such that area of the quadrilateral is 10 square units, then the locus of A is. Let's make any quadrilateral just. So let this point be A, B, C, and D. Yeah, given B is 2, 3, C is, let's write here, 5, minus 2. D is 1, minus 1, and I'm assuming A to have the coordinates as x, y. You are given that the area of the quadrilateral is 10 square units. That means I'll be using the matrices to solve the problem. So area of quadrilateral is 10 square units, which will give you half into xy, then 2, 3, 5 minus 2, 1 minus 1, xy. This is equal to 10. So let's open it. You will have 3x minus 2y minus 4 minus 15 minus 5 plus 2 plus y plus x. Okay, this is equal to 10. Let's solve. You have 3x, x, and this is going to give you 4x minus 2y plus y minus y minus 24 plus 2 minus 22. This is equal to, here was 1 by 2, this is equal to 20. 4x minus y minus 22. See, I'm removing this mod sign now. This is equal to plus minus 20. Because there is a mod sign, now I have to remove it. So this is equal to plus minus 20. Okay, the sum is further. So now there are two things. 4x minus y minus 22 is equal to 20. This gives you 4x minus y minus 42 is equal to 20. And the second one is 4x minus y minus 22 is equal to minus 20, which will give you 4x minus y minus 2 is equal to 20. These are the two equations. So from these two equations, the locus can be given by 4x minus y minus 42, 4x minus y minus 2 is equal to 0. So now let's check with the options. 4x minus y minus 42. Okay, fine. This is the one. Option D is the correct answer to the problem. Hope you understood this. Then let's move to the next question, number 42. A line makes intercepts 5 and 7 on the coordinate axis. The axes are rotated through an angle theta in the positive direction about the origin, so that the line makes equal intercepts on the new axis. Then tangent of theta is equal to. Okay. First is you have the intercepts at 5 and 7 on the coordinate axis. So x-intercept of the line is 5. So A is this. Also y-intercept of the line is 7. So B is this. Now equation of the line. X upon A plus y upon b is equal to 1. That is x upon 5, y upon 7 is equal to 1. Now, equation of the line with respect to old axis. Now, it is saying the axis is rotated through an angle theta. Before that, equation of the line with respect to old axis is 7x plus 5y is equal to 35. Now, it is said that the axes are rotated through an angle of theta. Now, I will replace x by x cos theta minus y sin theta and y by x sin theta plus y cos theta. Now, equation of the line L with respect to new axis is equation of the line with respect to new axis is 7 x cos theta minus y sin theta plus y x sin theta plus y cos theta is equal to 35. That gives you 7 cos theta plus 5 sin theta x plus 5 cos theta minus y 7 sin theta y is equal to 35. For for the x intercept, we have to put x is equal to 0. For x intercept, on putting x is equal to 0, the x intercept will be given by 35 upon 7 cos theta plus 5 sin theta. Sorry, this is 5 sin theta. Now, sorry, here I have to put y is equal to 0. For y-intercept, I have to put x is equal to 0. So it will be given by 35 upon 5 cos theta minus 7 y theta. Now you are given that they have the equal intercept to the new x's. So both the intercepts are equal. You are given that x intercept is equal to the y-intercept. That means 35 upon 7 cos theta plus 5 sin theta is equal to 5 cos theta minus 7 sin theta, which will give you 7 cos theta plus 5 sin theta is equal to 5 cos theta minus 7 sin theta. See, I'll connect the terms. 7 cos theta. Let's do one thing. I'll divide both the sides by cos theta. So this will be 7 plus 5 tangent of theta plus 5 minus 7 tangent of theta. This is gonna give me 2 is equal to minus 7 upon 5. Sorry. This is going to give me 2 is equal to minus 2 tangent theta 12. Or tangent theta is equal to minus 1 by 6. So this is the value for tangent theta. Correct. Let's take the mod because can't take the negative value. So this is equal to 1 by 6. This is what we had to find out in the question. Mod of tangent theta we needed to find, and that is equal to 1 by 6. Option B is the correct answer. Hope you understood this. Let's move to the next question. Question number 43. Before moving to the question, students, here's a quick reminder to visit our website www.examsnet.com. There you will find the PDF of this question paper as well as many more similar type of examination papers. You can also download our app. The link is available in the description box. So very best of luck. Do explore our website. Here we go with the question number 43. It says let L is equal to this is one of the diagonals of a square which is having these two as coordinates as the vertices. Then the coordinates of the two vertices lying on the diagonal L is equal to 0 are. Now, according to the question, let's make the figure first. You are having a square. So this is the square. Now, this is A, B, C, and D. Right? You have to find out the coordinates of two vertices which are lying on the line L is equal to 0. So let that be BD. Let BD. I have to find out the coordinates of BD. And this is lying on this line. Like BD is lying on the line 7x minus y plus 8 is equal to 0. And the coordinates of A, let it be minus 4, 5, B, 3, 4. All right. So let's make one more diagonal over here. You know the diagonal properties of the square. The diagonals of a square are equal and they bisect each other at the point of intersection. Okay. Now, I'll say let B, D be other two coordinates of the square lying on the line. 7x minus 5 plus 8 is equal to 0. So let the coordinates of B be x1. If I'm taking x1, then what will be y? See from here, y is equal to 7x plus 8. Okay, so this is equal to 7x1 plus 8. Similarly, the coordinates of D will be 7x2 plus 8. Now, let this point be M. So the coordinates of M is the midpoint of BD, diagonals bisect each other. M is midpoint of BD. That means M is having the coordinates. See, one thing. From here, M will have the coordinates as x1 plus x2 upon 2, also 7x1 plus 7x2 plus 16 upon 2. Right? From BD, M is also midpoint of AC. A is having the coordinates as minus 4, 5, and C is having the coordinates 3, 4. So what will be this? Minus 4 minus 3 upon 2. Five plus 4 upon 2. Sorry, here is plus 3. So this will be minus 1 by 2 and 9 by 2. Now, according to question, these two are same. So you can write it as x1 plus x2 upon 2 is equal to minus 1 by 2, which gives you x1 plus x2 is equal to minus 1. Okay. Similarly, from here, you will get the same thing. If you will put on 7x1 plus x2 plus 16 upon 2 is equal to 9 by 2, you will get the same answer, that x1 plus x2 is equal to minus 1. Okay. Now, you know one thing, the diagonals of a square bisect each other and they are equal. That means AM is equal to BM. Now, you know AM is equal to BM. So also I want to find out the distance. So M square is equal to BM square. What is AM square? Let's write down the coordinates. A was equal to minus 4, 5 and B was equal to x1, 7x1 plus 8 and M is equal to minus 1 by 2 and 9 by 2. So this gives you AM is equal to minus 4 plus 1 by 2 square and 5 minus 9 by 2 square is equal to BM. So this is equal to x1 plus 1 by 2 square plus 7x1 plus 8 minus 9 by 2 whole square. Let's solve it further. So this is equal to minus 7 by 2 square plus 1 by 2 square is equal to, let's open up this and plus 7x1, 16 minus 9, that's going to give you 7 by 2 square. So this is equal to 49 by 4 plus 1 by 4 is equal to x plus 1 by 2 whole square. So I'll take 7 common from here. This is going to give me 49. X plus 1 by 2 whole square. This is 50 by 4 is equal to 50 into x1 plus 1 by 2 whole square, which is x1 plus 1 by 2 is equal to plus minus 1 by 2. So that means you can have this x1 plus 1 by 2 is equal to 1 by 2, or x1 plus 1 by 2 is equal to minus 1 by 2. This is going to give me x1 is equal to 0 and this will give me x1 is equal to minus 1 by, this is going to give me x is equal to minus 1. Okay, so two values for x. If x is equal to 0, what will be the value of y? See, it was 7x plus 8. So y is equal to 8. Similarly, over here also y is equal to 7x1 plus 8. That is equal to 7 into minus 1 plus 8. That is 1. So the required coordinate of the two vertices will be 0, 8 and minus 1, 1. This is the answer to the question 0, 8 and minus 1, 1. Option A is the correct answer. Hope you understood this. Next is question number 50. So this question says the locus of the image of a variable point a, 2 alpha minus 1 with respect to this line is equal to what? Okay, so the locus of the image, I'll first of all say let this point be P. I'm naming this particular point as P, and its image with respect to this line will be, let's say that's Q represented by HK. This is the image of the point. Correct? That means H minus alpha upon 3. H minus alpha upon 3 is equal to K minus 2 alpha minus 1 upon minus 2 is equal to minus 2. Now, why minus 2 over here? I'll just discuss this. Let's write it first. So, this is minus 2. 3 alpha minus 2 into 2 alpha minus 1 plus 4. Whole divided by the square of 3 plus minus 2 square. 3 square plus minus 2 square. Okay. So now one thing, we were discussing like how did we get this formula? If there is a point x2 and see, there is this image is actually perpendicular. These 2 points, this point and the image, they are perpendicular to each other. And what is the general equation for that? General equation for point of intersection of a point to a perpendicular line, because the mirror will be perpendicular to the point. So this is given by x1, x2 minus x1 upon a is equal to y2 minus y1 upon b is minus ax1 plus by1 plus c whole divided by a square plus b square. So now y minus 2, because see, this is the point and this is the image. So the image, the distance gets doubled. That is why a minus 2 over here. Okay. So just this is the formula. Do remember this one because it will be used in some more questions also. Okay, let's get back to our problem now. We were solving this. Let's pick it up and solve it further. So this was equal to, let's write it again. H minus alpha upon 3 is equal to K minus 2 alpha minus 1 upon minus 2 is equal to minus 2, 3 alpha minus 2, 2 alpha minus 1 plus 4 whole divided by 3 square, that is a square minus b square. Okay. So H minus alpha upon 3 is equal to K minus 2 minus alpha, 2 alpha minus 1 upon minus 2 is equal to minus 6 alpha plus 4, 2 alpha minus 1 plus 8 whole divided by 13. This is gonna give me 2 alpha and minus 4 and this. See, this was minus 2, right? This is going to be minus 8. So give me a minute. This is equal to minus 8. So this is equal to 2 alpha minus 12 upon 13. Right now, let's pick up. You have h minus alpha upon 3 is equal to 2 alpha minus 12 upon 13. That gives you h minus alpha is equal to 6 alpha minus 36. This is 13h and 13 alpha. Okay, so this is going to give me h is equal to, let's write it again. So this is going to give me h is equal to 6 alpha minus 36 upon 13 plus alpha. That is 19 alpha minus 36 upon 13. Similarly, the second one, this, I'll pick up the k now. K minus 2 alpha minus 1 upon minus 2 is equal to 2 alpha minus 12 upon 13. That gives you k is equal to minus 4 alpha plus 12 plus 24 minus 4 alpha plus 24 upon 13, 2 alpha minus 1. So this is 26 alpha minus 13 minus 4 alpha plus 24 whole divided by 13. That will be 22 alpha plus 11 upon 13. That was equal to k. Okay, so this is the value for h and this is the value for k. From here, if I have to find out alpha, alpha will be equal to 13h plus 36 upon 19. And from here, alpha will be equal to 13k plus minus 11 upon 22. Now these two are of course equal. Let's equate them. 13h plus 36 upon 19 is equal to 13 alpha minus 11 upon 22. So 22 into 13h plus 36 is equal to 19 into 13 alpha minus 11. So this is the answer. Let's check with the options. 22 into 13x plus 36 is equal to 19. 13y minus 11 is option A. So this is the correct answer to the problem. Hope you understood this question. Next is question number 45. It says let M be the foot of the perpendicular drawn from this point to this line. Then the perpendicular distance of M to this line is. Okay, let's understand the situation. There is a point 5, comma minus 7. And this is the line 3x minus 5y plus 1 is equal to 0. Let's draw a perpendicular from here and let this point be M. You have to find out, yes, given this point is M, and you have to find out perpendicular distance from M to this line. Okay. So first thing, I'll be using the same general equation which we used in the last question. If I'm taking this M as the point of intersection of the perpendicular, actually this is the point where perpendicular from the point 5 comma minus 7 meets this line. So general equation will be given by x minus x2 minus x1. So this is x minus 5 upon 3 is equal to y plus 7 upon minus 5 is equal to minus ax1. So this is equal to 3 into 5 minus 5 into minus 7 plus 1 whole divided by a square upon b square. So this is 3 square plus minus 5 square. Correct? This gives me x minus 5 upon 3 is equal to y plus 7 upon minus 5. This on solving will give you 51 upon 34. Right? This is actually minus. Yes. So this is going to give me minus 3 by 2. Division by 17 table. So if I'm taking x minus 5 upon 3 is equal to minus 3 by 2. And the second one, y plus 7 upon minus 5 is equal to minus 3 upon 2. X will be equal to minus 9 upon 2 plus 5. So minus 9 upon 2 plus 5. And here y will be equal to 15 upon 2 minus 7. So this x will be equal to 1 by 2 and y will be equal to, again, 1 by 2. So your coordinates of m are 1 by 2, comma 1 by 2. Now the perpendicular distance of m, you have to find out perpendicular distance of m to this line. So now the situation is this. This m, and it's perpendicular to this line, 2x plus 5y minus 3 is equal to 0. You have to say this point is n. Actually, you have to find out the distance mn. You can do that easily, right? Perpendicular distance will be given by the formula 2 into 1 by 2 plus 5 into 1 by 2 minus 3 whole divided by root of 2 square, which is 4, plus 5 square, which is 25. And this is going to give me 1 minus 3. This is minus 2 plus 5 by 2 whole divided by root of 29. Okay, so this is equal to 1 by 2 root of 29 minus mod is there. So that's equal to 1 upon 2 root of 29. This is the answer to the question. And option A is the correct answer. Hope you got that. Let's move to the next question, number 46. It says if P is the point equidistant from all the vertices A, B, C of the triangle ABC, then PA is equal to. Now in this question, you are given A is minus 1, comma 3, B is 3 by 3, comma 5, and C is 5, comma 7. So if I'm taking the point P as xy, we are given that P is equidistant from A, B, and C, which simply means PA is equal to PB is equal to PC. Right? I'll pick up the first pair. So PA square is equal to PB square. PA, I have the coordinates. PA will be given by x plus 1 square, y minus 3 square. This is equal to x minus 3 square plus y minus 5 square. Open up. Is x square plus 1 plus 2x plus y square plus 9 minus 6y is equal to x square plus 9 minus 6x y square plus 25 minus 10y. You are going to cancel. And you will be left with only 8x plus 4y is equal to 24, or 2x plus y is equal to 6. Let's name this as equation 1. Now again, the second pair I'll pick up. That's PA square is equal to PC square. So this is x plus 1 square, y minus 3 square is equal to x minus 5 square, y minus 7 square. Open up. Plus y square plus 9 minus 6y, x square plus 25, y square plus 49 minus 14y. You will have 12x plus 8y is equal to 64. 3x plus 2y is equal to 16. And let's name this as equation number 2. So let's solve 1 and 2 equations simultaneously. Solving equation 1 and 2 simultaneously. Let's solve. So multiply this equation with 2. 4x plus 2y is equal to 12. 4x plus 2y is equal to 12. 3x plus 2y is equal to 16 minus 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 you will have x is equal to -4. And if x is equal to -4, you will find out the value of y comes out to be 14. So what is the coordinate for the point P? -4, 14. What do you have to find out in the question? PA. Okay. So B had the coordinates. B has this coordinates and A has the coordinates as -1, 3. PA will be given by root of -4 plus 1, 14 minus 3 square. That is equal to root of 9 plus 1 to 1, root of 130. So this is the answer to the question, root of 130. This is option D. Option D is the correct answer to the problem. Hope you understood this. Next is question number 47. Four different pair of lines are given in the list 1 and cosine of the angle between every pair of lines is given in list 2. You have to match them. I'll pick up all the equations one by one. So first is 5x squared plus this. Okay, let's write down first one. 5x squared plus 2 root 7 xy minus y square is equal to 0. So here tangent of theta, the formula is 2 root of h square minus ab whole divided by a plus b. What is h? It is half the coefficient of xy. A is the coefficient of x square, b is the coefficient of y square. So this is 2 root of 7 square minus 5 into -1 whole divided by a plus b. So that's going to give you 7 plus 5 upon 4, 2 root 12 upon 4. Root 12, you know, this is equal to this. So you will have tangent of theta is equal to root 3. And tangent of theta is equal to root 3 is at pi by 3. That means theta, this is equal to tangent of pi by 3. So which means theta is equal to pi by 3. So cos pi by 3 is equal to 1 by 2. Right. And that means A matches with third part. Okay. Okay. So A matches with third part. This is in all the options. Let's go with the B part. X squared plus root of 11 xy plus 2y square. X squared plus root of 11 xy plus 2y square is equal to 0. Here the tangent of theta will be equal to, again, the same thing. It was 2 root of h square minus ab upon a plus b. So 2 into root of root of 11 by 2 square minus 1 into 2 whole divided by 1 plus 2. This is 2 root of 11 by 4 minus 2 upon 3, which will give you root of 3 by 4 upon 4. And this will cancel. You will have 1 upon root 3 as the answer. And 1 upon root 3, this is at 10 pi by 6. That means theta in this case is pi by 6. So what is cos pi by 6? That is equal to root 3 by 2, which matches here. Okay, so B matches with the first option. This is B matches with the first option is here. This. Okay, so that means D is purely not valid. Let's move with the third option. C part. x square plus 2 root 2xy plus y square is equal to 0. Here tangent theta is equal to 2 root of h square, which is half the coefficient of xy. That means root 2 square minus 1 into 1 whole divided by 1 plus 1. So this is equal to 2 into root of 2 minus 1 upon 2, that is equal to 1. Correct? That means theta is equal to 45. This is equal to tangent of pi by 4. So theta is equal to pi by 4. Cos of pi by 4 is 1 by root 2. And that is option 5. So if C comes over here, C is with 5. C is with 5 is here and here. So that means B is invalid. Let's go with the next one. D part. Equation is 3x square plus 4 root 2 xy plus y square is equal to 0. Tangent of theta is equal to 2 root of 2 root 2 square minus 3 into 1 whole divided by 3 plus 1. So this is equal to 2. 4 into 2, 8 minus 3 upon 4 root of 5 by 2. So here I'll be using the formula 1 plus tan square theta is equal to secant square theta. So 1 plus 5 upon 4 is equal to secant square theta. That is 9 by 4 is equal to secant square theta, which gives you secant theta is equal to 3 by 2 or cos theta is equal to 2 by 3. Okay, so cos theta is equal to 2 by 3. This is option 4. So now you have A 3, B is 1, C is 5, and D is 4. And this matches with option C. So this is the answer to our question. Option C. Hope you understood this. Let's move to the next question, number 48. If ax squared plus 6xy minus 2y squared is equal to 0 represents a pair of perpendicular lines and this represents a pair of coincident lines, then what is the value of h? Now you are given that ax squared plus 6xy minus 2y squared is equal to 0 represent a pair of perpendicular lines, which simply means m1 into m2 is equal to minus 1. Okay, since they are pair of perpendicular lines, that means the product of their slope is going to be minus 1. Also, a upon minus 2, the formula for this is equal to minus 1, which gives you a is equal to 2. Now the second one, 9x squared plus 2hxy plus 4y square is equal to 0. It represents a pair of coincident lines. So this simply means 4, okay, y upon x whole square plus 2h y upon x plus 9 is equal to 0. So here, let the slope be y upon x. It actually represents the slope. So 4m. Let's put it m only, also. So 4m square plus 2hm plus 9 is equal to 0. Since they are the pair of, this represents a pair of coincident lines. In that case, the discriminant is equal to 0. Okay, so here you will have 4h square. Discriminant formula, I hope you know, this is b square minus 4ac is equal to 0. B is the coefficient of m, a is 4 and c is 9. So 4h square minus 4 into 9 is equal to 0. 4h square. Okay, I'll just divide both sides by 4. So h square minus is equal to 36, which gives you x is equal to 4. I'll divide, fine. So h square is equal to 36 Question number 48. If ax squared plus 6xy minus 2y squared represents a pair of perpendicular lines and 9x squared plus 2hxy plus 4y squared is equal to 0, where h is greater than 0 represent a pair of coincident lines, then you have to find out the value of h. So you are given that ax squared plus 6xy minus 2y squared is equal to 0. They are represents a pair of perpendicular lines, which means the product of their slope is equal to -1. You know this. Now, if two lines are perpendicular, then the product of their slopes is equal to -1. Also, this can be written as a upon -2 is equal to -1, which gives you a is equal to 2. Now, the second thing, 9 x square plus 2hxy plus 4y square is equal to 0. This represents a pair of coincident lines. Now let's divide both the sides by x square. You will have 4 into y upon x whole square plus 2 into h into y upon x plus 9 is equal to 0. You know y upon x, this represents a slope. So combined slope, this is 4m square plus 2h into m plus n plus 9 is equal to 0. Since the pair of lines, they are coincident, that means discriminant is equal to 0. That means b squared minus 4ac is equal to 0. 2h whole square minus 4 into 9 is equal to 0. 4h square minus 4 into 4 into 9 is equal to 0, or h square is equal to 36, which gives you h value s plus minus 6. And the question you were given h is greater than 0, so h is equal to 6. This is the answer. But I don't have h is equal to 6. Rather, all the options contain a. So this 6 can be written as a was equal to 2. So this is equal to 3 into 2 or 3a. That means h is equal to 3a. Option A is the correct answer. Hope you understood. Next is question number 49. The line x plus 2y is equal to k meets the curve this at 2 points A and B. Let O be the origin. If the line segments OA and OB are perpendicular to each other, then k is equal to. Now, given all the things which are given to us in the question, let's try and draw a figure for the problem. Okay. You are given this line meets the curve. So let this be the curve, some curve, right? This curve 2x squared minus 2xy plus 3y squared plus 2x minus y minus 1 is equal to 0. So let this be the curve. And this line x plus 2y, there is a line x plus 2y is equal to k. It is cutting this curve at the 2 points A and B. Now you are given that let O be the origin. So let origin be somewhere around here. So let O be the origin if the line segments OA and OB are equal. Okay. So first thing, combined equation of OA and OB is given by 2x square minus 2xy plus 3y square plus 2x into x plus y, 2y upon k minus y into x plus 2y upon k minus x plus 2y upon k whole square is equal to 0. So this is equal to 2x square minus 2xy plus 3y square plus I'll open up this. So you will have 2x square plus 4xy minus xy minus 2y square upon k minus x square plus 4y square plus 4xy upon k square is equal to 0. So let's take the LCM on both the sides. You'll have 2k square x square minus 2xy k square plus 3y square k square plus 2x square k plus 4xy k. This is actually 3, right? So 3xy k. Okay. Plus, wait, I was here. Minus 4y square k minus x square minus 4y square minus 4xy is equal to 0. So now let's take the coefficients of x square, y square and xy separately. You will have 2k square and here is 2k minus 1 x square plus minus 2k square plus 3k plus 3k minus 4 into xy plus 3k square minus 2k minus 4 into y square is equal to 0. Okay. Now you are given that OA and OB, they are perpendicular. That means A plus B is equal to 0. This is A and this is B. So 2k square plus 2k minus 1 minus 2k square plus 3k minus 4 is equal to 0. Here you have sorry, this is not B. This is B, coefficient of y square. So sorry for this. So this line will be changed to 2k square plus 2k minus 1 plus 3k square minus 2k minus 4 is equal to 0. That gives you 5k square minus 5 is equal to 0 or k square is equal to 1. That gives you k is equal to plus minus 1. And this is what we needed in the question. You had to find out the value of k. This is equal to plus minus 1. Option A is the correct answer. Hope you understood this question. Next is question number 50. Let the center of the circle S is equal to 0 lie on this line and also lies in the first quadrant. That means X and Y both are positive. If this circle touches the line this and this, then you have to find out the area of the circle. Let's try to make the figure first. This is the coordinate axis. This is the line. Y is equal to 5 and this is the line X is equal to 2. Now you're given the circle which is having it's a center which is lying on this line. It touches these 2 point lines. So this is the circle. Okay. The center of the circle, it lies on this line. So the coordinates, if I take this as x1, then what will be y? It will be 5 minus x1. Okay. And here is the origin. It's lying in the first quadrant, so circle is lying over here, definitely. I think we are done with the figure. We are done everything with the figure. Center lies on this line, and the first quadrant circle is touching these 2 lines. You have to find out the area of the circle. All right. So this is the center C. Perpendicular distance of C to the line y is equal to 5 or y minus 5 is equal to 0. This is equal to perpendicular distance of C to line x is equal to 2 or x minus 2 is equal to 0 since they both are radius. I'm taking this as A. So CA is equal to CB because both are the radius. That means 5 minus x1 minus 2 is equal to x1 minus 5. So 3 minus x1 mod is equal to x1 minus 5. If I'm removing the mod, so 3 minus x1 is equal to plus minus x1 minus 5. There are two cases. 3 minus x1 is equal to x1 minus 5, which is going to give me x1 is equal to 4. And the second case is 3 minus x1 is equal to minus x1 plus 5, which is absolutely not possible because these two will cancel and 3 is not equal to 5. So this is not possible. That means x1 is equal to 4 only. And if x1 is equal to 4, if this is equal to 4, what will be this? This will be 1. So the center is 4 comma 1. Center C is 4 comma 1. Now from here, you will calculate, see the radius, this is equal to 1. Right? If I'm taking, this is also the radius, this is also the radius. You can pick up anything from here. So that will give you radius is equal to 1. I got the radius, right? I hope you got this thing, right? Radius is equal to this. So 4 minus 5, that is 1. Now you have to find out area of circle. This is pi r square. So pi into 1, that is equal to 22 by 7 square units. So this is the answer. Okay, I don't have 22 by 7, but pi is there. That means option A is the correct answer to the question. Hope you understood this. Let's move to the next question, number 51. The straight line x plus 2y plus 1, x plus 2y is equal to 1, cuts the x-axis at A and y-axis at B. A circle drawn through A and B and the origin. The sum of perpendicular distances from A, B on the tangent drawn at origin to the circle S is. Okay, first thing, this line cuts x-axis at A and y-axis at B. So, somewhat like this. X-axis at A and y-axis at B. Therefore, this is the line equation, x plus 2y is equal to 1. So this point A will be given by 1 comma 0, correct? And B will be given by 0 comma 1 by 2. Now it said that a circle passes through A, B and origin. Circle passes through A, B and origin. So the equation of the circle, x square plus y square plus 2 gx plus 2fi is equal to 0. Now, since this circle is passing through A, therefore this can be written as 1 plus 0 plus 2g plus 0 is equal to 0, or g is equal to minus 1 by 2. Also, a minute, for point A. All right. Now, since this passes through B also for point B, this will be 0 comma 1 by 2. So this is 0 plus 1 by 4 plus 0 plus f is equal to 0. That is f is equal to minus 1 by 4. So now the equation of this circle is equal to x square plus y square minus, we got the value of g and h and I'm filling in the values. So minus x minus y by 2 is equal to 0. Now, so the tangent, you had to find out the sum of the perpendicular distances from A and B onto the tangent drawn at origin to the circle. Okay. So, tangent at 0, 0 is given by x, x1 y by 1, x plus x1 upon 2, half y plus y1 upon 2 is equal to 0. So this is equal to, since its tangent is a 0, 0. So this is 0 plus 0 minus x plus 0 upon 2 minus half y plus 0 upon 2 is equal to 0 minus x by 2 minus y by 4 is equal to 0. This will give me x plus 2 plus y. So this is equal to 0. So 2x plus y is equal to 0. This is the tangent at the origin. Now perpendicular distance. From to tangent at origin is 2 plus 0 upon root of 5, that is equal to 2 upon root of 5, and perpendicular distance from B, which was 0 comma 1 by 2, to the tangent at origin. See, this is equal to 0 plus 1 by 2 divided by root of 5, that is this. Now the sum of the perpendicular distances, sum of like 1 and 2 will be given by, it was 2 upon root 5 plus this. So I'll take 1 upon root 5 common, 2 plus 1 by 2, 5 by 2, root of 5, or root of 5 by 2, right? Center will be given by, so this is, right, F was this, and sorry, this is G. Okay, so this is equal to, fine, this is the center, minus G minus F. G was equal to minus 1 by 2 and F was equal to minus 1 by 4. This is the center. What you have to find out the next? The sum of the perpendicular distances from to the tangent drawn the circle is. Okay. What is the radius? Root of G square plus F square minus C. Now G is 1 by 2, square is 1 by 4. This is 1 by 16 minus 0. So that gives you this is 5 upon 16, right? So that is root 5 upon 4. This is the radius. Diameter is 2 into radius. So that means it is root 5 by 2. So these two are equal, root 5 by 2. And here also we calculated root 5 by 2. That was the sum of the perpendicular distances. So sum of the perpendicular distances is equal to the diameter. Sum of the perpendicular distances is equal to the diameter of the circle S. That means we have option B as the correct answer. Hope you understood this. See, there was not a direct answer given to us in the question as root 5 by 2. So we calculated that the center is this, and for that we also calculated the radius is root 5 by 4. I needed to go to root 5 by 2. That was the only possible way, that this is the diameter. Okay, hope you understood this. Then let's move to the next question. Question number 52. Let P and Q be two external points of the circle S is equal to x square plus y square minus a square is equal to 0. Let the chord of contact of the point P with respect to the circle S is equal to 0 passes through the Q. If L1 and L2 are the lengths of the tangents drawn from P and Q to this circle, then you have to find out the length of PQ. Okay, so first of all, let's say the P to be the point having the coordinates as x1, y1, and Q to have it as x2, y2. Equation of chord of contact. Equation of chord of contact of the point P is given by x into x1 plus y1 minus a square is equal to 0. Now Q lies on the chord of contact. Therefore, on the chord of contact, therefore, see, this will be written as x1, x2 plus y1, y2 minus a square is equal to 0. You are also given that L1 and L2 are the length of the tangents drawn from P and Q to this circle. Therefore, L is equal, if I'm taking, you are given that L1 is the length of the tangent drawn from P. So L1 will be given by root of x1 square plus y1 square minus a square, and L2 will be given by root of x2 square plus y2 square minus a square. Okay, next, what do you have to find out? You have to find out PQ. So PQ will be given by P is having the coordinates as x1, y1, and Q is having the coordinates as x2, y2. So this is equal to root of x2 minus x1 whole square plus y2 minus y1 whole square. Let's open it up. You will have x1 square plus x2 square minus 2x1 x2, y1 square plus y2 square minus this is so minus 2 y1 y2. Okay, so you can write it as x1 square plus y1 square plus x2 square plus y2 square minus 2. I'll take common x1 x2 plus y1 y2. Okay, so this is equal to root of, now x1 plus x2 whole square. See, this is equal to, from here you can write down this as L square plus a square is equal to x1 square plus y1 square. Also from here, L2 square plus a square is equal to x2 square plus y2 square. So this is equal to L1 square plus a square plus L2 square plus a square minus x1, x2 plus y1, y2. See, from here, x1, x2 plus y1, y2 is equal to a square. So I have used these three equations, 2 and 3. So this is equal to 2 into a square, right? This will cancel out and you will have this as L1 square plus L2 square whole under the root. That is the value of PQ, which is option C. So here we have option C as the answer to the question. Hope you understood this. Next is question number 53. It says, if A x1 y1 is the internal center of the similitude and B x2 y2 is the external center of similitude of the two circles C1 and C2 with the centers P and Q respectively. We are given PA is 3, AB is 5, QB is 2. You have to find out the ratio of the radii of the two circles. Let's make the figure first to understand the problem. Here's a circle. Here are the two circles. This is the bigger one, and let's take this one to be the smaller one. Now, A x1 y1 is the internal center of similitude. Okay, let's make that. Let's make the, and this is Okay, actually, this is not meeting. Not so good with the drawing. Okay, so this A is the internal center of similitude. And B is the external one. Let's make the external one also. And this is the external one. This is touching the circle. And this is the point B. Okay, so centers are, this is having the center as P, alpha, beta, and this one is having the center as Q, that is gamma and delta. Also, you are given that PA is equal to 3, QB is equal to 2, AQ is equal to 3, and AB is equal to 5. P is equal to 3. Wait, this is P and this. Okay. Now, how is AQ is equal to 3? You have AB as 5 and AQ as, this AB is 5 and BQ is 2. That means AQ, this is AB minus BQ. That means it's 3. Okay. Now, let's move further. Oh, okay. Now, one thing. You know one thing, the internal, this is important to note, internal center of similitude divides the line joining the center in the ratio R1 is to R2, right? That means PA upon AQ is equal to R1 upon R2. Now, these two both were 3, which simply means R1 is to R2 is 1 is to 1. You needed to find this ratio. 1 is to 1. Option C is the correct answer. Hope you understood this. Next is question number 54. The equation of the direct common tangent to these two circles is, okay, here you have these two circles. This is circle 1 and circle 2. Let R be any point. Now, this point is drawing the common tangent. Equation of the direct common tangent, you have to find out the equation of this line. The first circle is S1, x squared plus y squared minus 6x minus 4y minus 23 is equal to 0, and S2 is given by x squared plus y squared plus 2x plus 2y plus 1 is equal to 0. Here the center, you know, it's minus g minus f. G is half the coefficient of x and f is half the coefficient of y. That means the center is 3, 2. Here the center will be minus 1, minus 1. And the radius, that's given by g squared plus f squared minus c. So g squared is 9 plus 4 minus plus 23. This gives you 36. That means radius is 6. And here the radius is 1 square plus 1 and minus of 1, that is going to give you 1. Okay, so we have this as radius 1, this has the radius 2. Now, see, R is dividing circle C1, S1 actually. C1, okay, whatever, like you can say here, you can say S1 and S2 in the ratio 6 is to 1 externally. Right? So the coordinates of R will be given by 6 into minus 1 plus minus 3 into 1 whole divided by 6 minus 1, and 6 into minus 1 plus 2 into -1. Actually, -1 was supposed to be here upon 6 minus 1. So the coordinates of R will be -9/5 minus 8/5. Now, equation of the tangent through R is equation of the tangent through R is 5y plus 8 is equal to 5mx plus 9m. How did you get to this? Y minus, that is minus minus plus, y plus 8/5 is equal to m into x plus 9/5. This will give me 5y plus 8 is equal to 5mx plus 9. That will give you 5y plus 8 is equal to 5mx plus 9m. Okay. So, distance from C2, that is minus 1 minus 1 to the tangent is equal to the radius. See, this was your center to C2, which is having the coordinates as -1 -1, and this was C1, which had the coordinates as this. The radius over here is 1 and the radius over here was 6. Now the distance of this central point C2 to the tangent is obviously the radius of the circle. That means this is equal to 1. Okay, so this will be given by minus 5m plus 5 plus 9m minus 8 whole divided by root of 25m square plus 25. This is equal to 1. So you will have 4m minus 3 upon, I'll take 5 outside, m square plus 1 is equal to 1, which gives me 4m minus 3 upon 5. This is equal to 1. Squaring both sides, you will have 16m square plus 9 minus 24m upon 25m square plus 1 is equal to 1. So this will be equal to 16m square plus 9 minus 24m is equal to 25m square plus 25, or 9m square plus 24m plus 16 is equal to 0. So this is, see, this is equal to 3m plus 4 whole square. This will give you m is equal to minus 4/3. Now let's fill this value of the m in the given equation, this one. Okay, so this equation 1 will become, in equation 1, this will become y plus 8/5 is equal to minus 4/3 into x plus 9/5. Actually, I'm using this one because this is easy. I have to fill m only at this place. Ultimately, this equation will lead to this one. So no issues. You can use this equation or this equation. Both will give you the same answer. Okay. So, okay, let's solve it further. Now you have y. Let's multiply both the sides by 3. So, actually 15. This will give you 15 y plus 24 is equal to minus 20 x plus 9/5. So this is 15y plus 24 is equal to minus 20x, and this is going to give me minus 36. So 20x plus 15y, 20x plus 15y plus 60 is equal to 0, or 4x plus 3y plus 12 is equal to 0. So this is the equation we wanted for. We wanted to find out the equation of the direct common tangent, and that is 4x plus 3y plus 12 is equal to 0. That is option C. Hope you understood. Let's understand the whole problem once again. So you had to find out the equation of the direct common tangent to these two circles. The center of these two circles, we found out center was 3, 2. Here the center was minus 1, 1. Also, we calculated the radius for the two circles. Now, this point R is dividing the two circles externally in the ratio. Wait. Okay, this point R is dividing the two circles externally in the ratio 6:1. So that means R will have the coordinates as, you will solve and you will find out the R will have the coordinates as minus 9/5 and minus 8/5. You had to find out the equation. Now this point lies on that, this R point lies on that tangent. Therefore, the equation can be calculated as y minus y1 is equal to m into x minus x1. So I have calculated using this point. This is the equation we have framed. Correct. Also, see, C2 distance from C2 onto this line, this is equal to 1. So we got the equation of the line already. We solved the form. We used the formula to find out the distance, that is the radius of the smaller circle, second circle. From there, you calculated the value of m to be equal to minus 4/3. And now I will fill this value in that equation of the tangent, which we assumed we just were falling short of the slope of that tangent. So after filling in to the slope of that tangent, you got the final equation of the common tangent as 4x plus 3y plus 12 is equal to 0. Hope you understood this. Let's move to the next question. Question number 55, the length of the common chord. Okay, the length of the common chord of these two circles is, you are given these two circles. Let this be C1 circle, let it be S1. So x squared plus y squared minus 4x minus 8y plus 4 is equal to 0, and S2 is x squared plus y squared minus 8x minus 12y plus 16 is equal to 0. You know, center is minus G minus F. Using that, the center is 2, 4, and here the center, let this be C1, and here the center will be 4, 6. Okay. Now let's calculate the radius. It's G square, root of G squared plus 8 F squared minus C squared. So that's 4 plus 16 minus of 4, which will give you 4. And here the radius, let it be R2, and this be radius 1. So this is equal to 4 square is 16 plus 36 minus 16. So it will be 6. We got the two centers, we got the two radius. Let's frame the figure now. We are having, this is the smaller circle C1, having the center at 2, 4, and this is radius is 4. This is a bit bigger one, and you have to find out the common chord, so they are intersecting circles. Okay, here you have the center C2 as 4, 6, and the radius in this case is 6. Let's make it here. Okay, so let this be the common chord to both the circles, PQ. So this is P and Q. Now, okay, I think we have written everything. Now, equation of the common chord will be, equation of common chord is given by S2 minus S1 is equal to 0, and it's x squared plus y squared minus 8x minus 12y plus 16 minus x squared minus y squared plus 4x plus 8y minus 4 is equal to 0. So these are going to get cancelled, and you will have minus 4x minus 4y plus 12 is equal to 0, or it will give you x plus y is equal to 3. Okay, this is the equation of the common chord. Now this is C, and let's say this is M, this point. The point of intersection over here, this point, this particular, if you can see, this point I'm taking as M. So C1M can be written as, I'm doing this for a purpose, you'll just come to know about it. So C1M will be, it will be 2 into 1 plus 4 into 1 minus 3 upon root of 1 square plus 1 square. This is equal to, it's going to give me 3 by root 2. Okay. So C1M is equal to 3 by root 2. Over here, what we need to find out is the length of the common chord. So basically, if I find out PM, so length will be simply the double of it. PQ is double of PM. If I can find out PM over here, you know this is falling perpendicularly. The center C1 is falling perpendicularly on the line PQ at point M, right? So this, if I'm taking this triangle, CPM, in triangle CPM, C1PM actually, sorry. So in triangle C1PM, C1P square is equal to C1M square plus PM square. C1P, this is the radius of the circle C1, which is 4. So 4 square is equal to C1. We just calculated it is 3 upon root 2. See, we just calculated. And PM, I need to find out. Okay. So this is 16 minus 9 upon 2 whole under the root is equal to PM. That's 32 minus 9. 32 minus 9 is going to give me 23. So root of 23 upon 2, this is PM. And what is PQ? It's twice of PM. So twice of this. That is equal to, I'll take it inside. This will become 4. So that is equal to 46, root of 46. Okay. So we have option A as the answer to the question. Okay, you had to find out the length of the common chord, that was PQ. I tried to find out PM, and for that, I know the C1P, this is equal to 4, and I just need to find out C1M. For that, I found out the length, the equation of the common chord, and I found out C1M actually. And from there, you can calculate PM to find out, ultimately find out PQ. Hope you understood this question. Right, we have option A as the answer. Next is question number 56. If the focal chord drawn through the point 1, 2 on this parabola meets the parabola in x1, y1 and x2, y2, then, okay, first thing, you have the parabola y square is equal to 8x, that is equal to 4ax, which simply means A is equal to 2. Right? So if I take this parabola, this is this type of parabola. Sorry. Okay. Now, the focal chord through the point 1, 2. There is a focal chord. Let this be point A, 1, 2. Okay. Let's say P is having x1, y1 is point P, and Q is, let's say this is point P, and this Q is x2, y2. Okay. So equation of, this is the focal point. This is given by 2, 0. Now, AF will be written by y minus 0 into is equal to M. M is given by 2 minus 0 upon 1 minus 2. This is the slope of AF multiplied by x minus 2. So y is equal to minus 2 into x minus 2, or y plus 2x is equal to 4. So this is the equation of the line AF. Now intersection, of the curve and the line AF. This is the line, and the intersection point of the line AF and the curve will be intersection of the curve and the line AF will be given by, see, the curve was y square is equal to ax, and this is the curve. So from here, y is equal to 4 minus 2x. You can write down 4 minus 2x square is equal to 8x, or I'll take 2 common from here. So 2 square is 4. This will give me 2 minus x square is equal to 2x. Let's open it now. X square plus 4 minus 4x is equal to 2x, or x square plus 4 minus 6x is equal to 0. Now you had to find out the factors, the two roots. What you had to find out, x1 plus x2. See, x1 plus x2, these are the two roots. The sum of the roots is given by minus b upon a. So this is equal to minus of minus 6 upon 1, that is equal to 6. So x1 plus x2 is equal to 6. We have option C as the answer. Hope you understood this. Next is question number 57. If 2t square, 4t is a point on this parabola such that the focal distance is equal to 3, then you have to find out the value of t. So this is the given parabola. This is the given parabola. It's given that the focal distance is 3 and this point is lying on the parabola. So if this point is 2t square, 4t, that means this distance is equal to 3. The focus over here, the A, similarly A is equal to 2. I hope you know like A is equal to 2. So the focus is given by 2, the coordinates as 2, 0. These are the coordinates for the focus. You are given the focal distance is equal to 3, which means 2t square plus A is equal to 3. A is already 2, so 2t square is equal to 1, or t square is equal to 1 by 2, or t is equal to plus minus 1 upon root 2. So we have option D as the answer. Hope you got that. Let's move to the next question. Question number 58. The length of the latest rectum of an ellipse is 6 units and the distance between the focus and the nearest vertex on the major axis is 5 by 3 units. If E is the centricity of this ellipse, and then E satisfies which of these following equations? Okay. So first thing, you are given the length of the latest rectum is equal to, where it is? Yeah, the length of the latest rectum is 6. Length of latest rectum is equal to 6. That means 2b square upon A is equal to 6, or b square upon A is equal to 3. Now the distance between the focus and the nearest vertex and the nearest vertex on the major axis is equal to 5 by 3. Which means this A minus AE is equal to 5 by 3. That means A1 minus E is 1 by 3. So let's name this one as 2 and this equation as 1. Okay. So now you know one thing more, that E square is equal to 1 minus B square upon A square, which gives you E square is equal to, see, I can write it like this, B square upon A square like this. So this is equal to, wait, this gives you, this is equal to 1 minus this. Okay. Now, E square is equal to 1 minus B square upon A. We just calculated from 1. B square upon A was equal to 3. And 1 upon A. 1 upon A from here can be written as 3 by 5. 1 minus E. So this is equal to 3 by 5. 1 minus E. This gives you E square is equal to 1 minus 9 by 5, 1 minus E. Let's do the cross multiplication with 5. So 5E square is equal to 5 minus 9 plus 9E. 5E square minus 9E plus 4 is equal to 0. Okay. So let's factorize it. 5E square minus 5E minus 4E plus 4 is equal to 0. So the two factors will be 5E minus 4 and E minus 1 is equal to 0. Now E can't be equal to 1. That means E is equal to 4 by 5. Okay. Now let's check 4 by 5 is satisfied by which equation. Let's check the first one. So E was 4 by 5, 25 into 4 by 5 square minus 40 into, I'll do it downwards. So let's pick up the first option, A. A option was 25x square minus 40 minus 25x square minus 40x plus 16 is equal to 0. So 25 into 16 upon 25 minus 40 into 4 upon 5, that's 8, plus 16 is equal to 0, which is not true. Wait. Okay, so this is going to give me this. Okay, sorry, this is true. This will cancel out. And that means we don't need to solve further options. We got option A as our answer because option A satisfies E is equal to 4 by 5. Hope you understood this. Next is question number 59. If the line 2x minus 3y plus 4 is equal to 0 cuts this ellipse in A and B, and alpha beta is the midpoint of AB, then 3 beta minus 2 alpha is equal to. So basically you have to find out the values of alpha and beta. You are given that x is equal to 3 cos theta and y is equal to 5 sin theta. You know, sin square theta plus cos square theta is equal to 1. That gives you y by 5. I'll write with x. So x square by 9 plus y square by 25 is equal to 1. This gives you 25x square plus 9y square is equal to 225. Now line 2x minus 3y plus 4 is equal to 0 cuts the ellipse in A and B. Line 2x minus 3y plus 4 is equal to 0 cuts ellipse in A and B. So here two things will be there. Y is equal to 2x plus 4 upon 3 and x is equal to 3y minus 4 upon 2. Now let's fill in this y in this equation. You will get 25 x square plus 9 2x plus 4 upon 3 whole square is equal to 225, or 25 x square plus 4x square plus 16 plus 16x is equal to 225. 29x square plus 16x minus 209 is equal to 0. So now the sum of the two roots will be given by minus b upon a. So that is equal to minus 16 upon 29. Now I'll fill the x value just like I filled y in this equation. Now even I will fill in x in this equation. You will get 25 3y minus 4 upon 2 square plus 9y square is equal to 225, or 225 y square minus 600y plus 400 plus 36y square is equal to 900. This will give you 291y square minus 600y minus 900 is equal to 0. Now the sum of the two roots minus b upon a, that is 600 upon 291. This is a and this is b. Okay. So a is having the coordinates as x1, y1 and b is having the coordinates as x2, y2. What is the midpoint of AB? This will be given by x1 plus x2 upon 2, y1 plus y2 upon 2. So this will be given by minus 8 upon 21 and see, this will be cancelled 200, 600 and this will be 200 divided by 97. Okay, so this will be 100 upon 97. Right? So you are given that this is alpha and beta is the midpoint. So this is alpha and beta. This is alpha and this is beta. You have to find out 3 beta minus 2 alpha. That's equal to 100 upon 29. See this when I multiply this with, okay, let's see, do it again. Multiply by 3 minus okay. Yeah. So minus you will have a plus over here and 8 upon 29 into 2. This will give me here's a slight change. This 225 plus 36, this was supposed to be 261. Okay, so here is 261, which will give you 87 over here. And here is 87 as well. And this is 87. So 87 divided by 3 gives you 29. So 100 upon 29 plus 16 upon 29. This is going to give you 116 upon 29. This will cancel at 4. Okay. And you have option B as the answer. Hope you understood this. Let's understand the whole problem once again. You were given that this line is cutting this ellipse in A and B, and alpha and beta are the midpoints of AB. So first of all, I framed an equation, right? X square upon 9 is equal to plus y square upon 25 is equal to 1. So using this, since this line is cutting this, the point of intersection, I found out the point of intersection, for the point of intersection, these are the two equations which were formed, and x1 plus x2 and y1 plus y2, these two equations we framed. You know the points of intersection A and B. A was given by x1, y1 and B was given by x2, y2. The midpoint of A will be x1 plus x2 upon 2, y1 plus y2 upon 2. And the sum we know, this is equal to minus 16 upon 29 and this is equal to not minus 200 upon 87. Okay, so using that, the midpoint is minus 8 upon 29, comma 100 upon 87. You have to find, now this was equal to alpha and beta. You have to find out the value of 3 beta minus 2 alpha, which on solving will evaluate to 4. Therefore, we have option B as the answer. Hope you understood this. Let's move to the next question, number 60. Let E1 be the eccentricity of the hyperbola for which the distance between its foci is 2 times the distance between its directrices, and E2 be the eccentricity of another hyperbola for which the length of its transverse axis is twice the length of its conjugate axis. Okay. So E1, you know, this is the eccentricity of the first hyperbola you are given over here. You are given x square upon a square minus y square upon b square is equal to 1. Now you are given that the distance between the foci is 2 times distance between its directrices. Distance between the foci is 2 times distance between its directrices. That is 2a(E1) is equal to 2 into 2a upon E1. Sorry. So these will cancel and you will have E1 square is equal to 2 or E1 is equal to root 2. Now let E2 be the eccentricity. It's actually given. E2 is the eccentricity of the second hyperbola. For the second hyperbola, you are given the length of the transverse axis is equal to twice the length of conjugate axis. Okay, so that means if I'm taking the coordinates next, now the variables a dash and b dash. So 2a dash is equal to twice 2b dash. That means a dash is equal to twice b dash. Also, E2 square is equal to 1 plus b square upon a square, which gives you E2 square is equal to 1 plus b, sorry, this is b dash and a dash. Okay. So b dash upon a dash from here is equal to 1 by 2. So this is equal to 1 by 4. That gives you 5 by 4, E2 square. So E2 is equal to root 5 upon 2. Okay, you have to find out E1, E2. This is what you need to find out. We just calculated E1, that's equal to root 2. So root 2 into root 5 upon 2, that's going to give me root 5 upon 2. Okay. Yes, root 5 upon 2. This is not in the options. Okay, I have root 5 upon 2. This can also be written as root 10 upon 2. Like multiplying the numerator and the denominator with 2. So we have option B as the answer. Hope you understood this. Let's move to the next question then. Question number 61, assertion. The distance between the points P pi by 4 and P pi by 3 on this hyperbola is this. And the reason for the same is x is equal to a cos ht, y is equal to b sin ht are the parametric equations for this hyperbola. So which of the following is correct? Assertion and the reason. Let's pick up the first one, assertion. If I'm taking this equation, 9x squared plus 16y squared is equal to 9. This can be written as dividing both sides by 9. This will give you x square plus y square upon 3 by 4 square is equal to 1. Now, this is not the equation for the hyperbola. So, assertion A is wrong. And the reason, of course, this is true. X is equal to A cos ht, y is equal to this. They are the parametric equations for this hyperbola. This is absolutely true. That means we have option D as the answer. Hope you got that. Next question number 62. Let A, B, C, D. These are the 4 vertices of the tetrahedron. Let's make the tetrahedron first. So actually, this is a triangular pyramid. I'm not done like so good in drawing, so this is not the appropriate one. But still, now you're given that G1, G2, G3, and G4. They are the centroids of these 4 faces. Okay. So let's make it something like this. Okay. So this is actually a triangular one like this. Okay. So now the 4 faces A, B, C, D are there. A coordinates are 1, 1, 1. B is 1 minus 4, 3. C is 2 minus 2 and 0. And D is 8, 1, 4. They are the vertices of the tetrahedron. Now G1, G2, G3, G4, they are the centroids on ABC, BCD, CDA, and DAB respectively. So G1 is a centroid of the face ABC. So this will be G1 will be given by You know the formula for this. I'm talking about the general formula for the centroid. This is given by x1 plus x2 plus x3 upon 3 and y1 plus y2 plus y3 upon 3, z1, z2, z3 upon 3. So g1 is equal to, this is 1 plus 1 plus 2 upon 3, 1 minus 4 minus 2 upon 3, 1 plus 3 plus 0 upon 3. That's equal to 4 by 3 minus 5 by 4, 3 and 4 by 3. So these are the coordinates for G1. Similarly, G2. G2 is the centroid on the face BCD. So let's pick up B, C, and D. So G2 will be given by 1 plus 2 plus 8 divided by 3 minus 4 minus 2 plus 1 divided by 3, 3 plus 0 plus 4 divided by 3, which will give you the coordinates as 11 by 3 minus 5 by 3 and 7 by 3. Similarly, G3, this is the centroid on the face CDA. So let's pick up CDA now. So G3 will be given by 1 plus 2 plus 8 upon 3, 1 minus 2 plus 1 upon 3, and 1 plus 0 plus 4 is upon 3. That is equal to 11 by 3, 0 and 5 by 3. G4, this is the centroid on the face DAB. It's okay. So G4 will be given by 1 plus 1 plus 8 upon 3, 1 minus 4 plus 1 upon 3, 1 plus 3 plus 4 upon 3. That's equal to 10 by 3 minus 2 by 3 and 8 by 3. Now the centroid, you have to find out the centroid of the tetrahedron, which is made by these G1, G2, G3 and G4 as the vertices. So if this is G1, G2, backside G3 and G4. So I'll form a tetrahedron using the vertices G1, G2, G3, G4. You have to find out the centroid of the tetrahedron. Okay. Okay. So centroid of tetrahedron with G1, G2, G3 and G4 as vertices is given by, let it be G. This is given by the x coordinate of all of them divided by 4 plus comma y coordinate of all of them divided by 4 comma the sum of z coordinates of all of them divided by 4. So this will give you 4 by 3 plus 11 by 3 plus 11 by 3 plus 10 by 3 whole divided by 4 comma minus 5 by 3 minus 5 by 3 plus 0 minus 2 by 3, 4 by 3, this whole is divided by 4, 4 by 3 plus 7 by 3 plus 5 by 3 plus 8 by 3 divided by 4. So that's cool. That will give you, this is 22, 30, 22 and 32, 36 upon 3. So this will give you 3. Comma minus 1 comma 2. So these are the coordinates for the centroid of the tetrahedron, which are formed using these coordinates as the vertices 3 minus 1 comma 2, which is option D. So this is the answer to the question. Hope you understood. Let's move to the next question. Question number 63. Let A, B, C are the vertices of the triangle ABC. Then D is the point where the bisector of angle BAC meets BC. Let's make the figure. So let this be the triangle ABC. A, B, C. This is 2, 3, minus 1. This is 4, 1, 0, minus 1, and 11. So next, D is the point where the bisector of angle BAC meets BC. Let's say this is the point D. Now you have to find out the direction ratios of AD. All right. So first of all, let's go with the direction ratios of BA will be given by B minus A. That is 4 I cap plus J cap, and K is missing. So let's write it as 0 K cap minus 2 I cap plus 3 J cap minus K cap. This will give you 2 I cap minus 2 J cap plus K cap. Okay, the direction ratios of AB. Similarly, direction ratios of AC are C minus A, which are minus I cap minus J cap plus 11 K cap minus 2 I 3J minus K. That gives you minus 3I minus 4J plus 12K. Now, AD is the bisector of angle BAC. Therefore, because AD is bisector of angle BAC, so AD will be given by AB upon the modulus of AB plus AC vector upon the modulus of it. So this is 2I minus 2J plus K upon 3 plus minus 3I minus 4J plus 12K upon 13. I hope you know this, like this 3 module I just saw. Modulus of AB is equal to root of 2 square plus minus 2 square plus 1 square. That is equal to root 9. That's 3. And mod of AC is minus 3 square minus 4 square 12 square. So this is 9 plus 16 plus 144, which is equal to 30. Okay, so now let's get back to here. AD is equal to, this will be on solving, will give you 26I minus 26J plus K minus 3I minus 4J plus 12K. Sorry, this has to be multiplied by 3. So this will be minus 9I minus 12J plus 36K whole divided by 39. So this is 26 minus 9, 17I minus 38J plus 49K. Okay, this is actually 13K whole divided by 39. So the direction ratios are 17 upon 39 minus 38 upon 39 and 49 upon 39. That simply means the direction ratios are 17 minus 38 and 49. So this is the answer to the question. Let's check with the options. We have option C as the correct answer. Hope you understood this. Then let's move to the next question, number 64. If a plane passing through these 3 points meets X, Y, Z in ABC respectively, then A is equal to. Okay, so a plane is passing through these 3 points. Equation of a plane passing through 3 points will be given by. Let's write the general formula for this first. Equation of a plane passing through 3 points x1, y1, z1, x2, y2 and z2, x3, y3 and z3 is given by x minus x1, y minus y1, z minus z1, x2 minus x1, x3 minus x1, y2 minus y1, y3 minus y1, z2 minus z1, and z3 minus z1 is equal to 0. Now let's fill in the values x1, x2, x3. We are given in the question. This becomes x minus 2, 0. X minus 2, 0 minus 2 minus 2, comma, minus 2 minus 2. This is y minus 3 minus 5 minus 3 and 0 minus 3, z minus 0, 2 minus 0, 3 minus 0 is equal to 0. Okay, let's write in the simplified form. This is x minus 2 minus 2 minus 4. Question number 64. A plane passing through these 3 points meets x, y, z axis in A, B, C respectively. Then you have to find out the coordinates of A. One thing is for sure, A will have the coordinates of the form x, comma 0, 0. Right? Now, the equation, general equation of plane passing through 3 points. Let's say that x1, y1, z1, x2, y2, and z2, x3, y3, and z3 are given by, is given by x minus x1, x2 minus x1, x3 minus x1, y minus y1, y2 minus y1, and y3 minus y1. Similarly, z minus z1, z2 minus z1, and z3 minus z1. So you are given the 3 points. So this particular equation will become x minus 2, y minus 3, z minus 0, 0 minus 2, minus 2, comma, minus 2, minus 2, minus 5, minus 3, and 0 minus 3, 2 minus 0, and 3 minus 0. This is equal to 0. Okay. Let's simplify. X minus 2. Here is minus 2, minus 4, y minus 3, z minus 8, minus 3, 2, and 3 is equal to 0. So let's expand it. You will have x minus 2 minus 24 plus 6 minus of y minus 3 minus 6 plus 8 plus z minus minus plus. This is going to give me 6 minus 32. So this will be 18. This whole was equal to 0. 18x minus 2 minus y minus 3 into 2. Okay. And this is minus 26. Z is equal to 0. Okay. So one thing is, this is minus 18. Yes. Okay. So now let's divide both the sides by minus 2. You will have 9x minus 2 plus 2y minus 3 plus 13. Z is equal to 0. Now, if the plane cuts the x-axis, it said it cuts the x, y, z axis in A, B, C respectively. You have to find out the coordinates of A. So let's say the coordinates of A are, let's say A coordinates are x, 0, 0. So using this equation, you have 9x minus 2 plus 2 into minus 3 plus 0 is equal to 0. 9x minus 18 minus 6 is equal to 0, which gives you 9x is equal to 24. Here's a slight change. I divided both the sides by 2. So this 2 will vanish and I have minus 3 over here. So let's write this equation again. 9x minus 18 minus 3 is equal to 0, which gives 9x is equal to 21. Or x is equal to 21 upon 9, that is 7 upon 3. So definitely the coordinates of A become 7 upon 3, comma 0, comma 0, which is option B. Hope you understood this. Let's move to the next question, number 65. If this represents greatest integer less than equal to x, then fx is equal to this. If limit x approaching 2 minus fx is equal to L1 and the limit approaching x2 plus x approaching 2 plus fx is equal to L2, then you have to find the sum of L1 plus L2. Okay, first thing, this is the greatest integer function. So now L1 you are given is limit x approaching 2 minus fx. So this will be written as limit h approaching 0 f of 2 minus h, which is equal to limit h approaching 0 to 2 minus h minus greatest integer function. It is 2 into 2 minus h. That is limit h approaching 0, 4 minus 2h minus. So see, this is something 4 minus h. Correct? Greatest, since this is the greatest integer function, so this is equal to 3. I hope you remember, right? The greatest integer function for 2.2, this is equal to 2. And for even 2.9, this is equal to 2. So using the same concept, 4 minus h, the greatest integer function will give you 3. So 4 minus 2h minus 3, this will give you 4 minus 3, that is equal to 1. Similarly, limit x approaching 2 plus, this is L2, fx is equal to limit h approaching 0, f of 2 plus h, that is limit h approaching 0 to 2 plus h minus greatest integer function 4 plus 2h. This is the same thing, right? 2 plus h. Okay, so this is limit h approaching 0, 4 plus 2h minus 4 plus 2h. So according to that, this is equal to 4. Limit h approaching 0, 4 plus 2h minus 4. This is gonna give you 4 minus 4, that is equal to, this will evaluate to 0. This is L2. You had to find out L1 plus L2, which is equal to 0 plus 1, that is 1. So 1 is the answer to the question. Option A is the correct answer. Question number 65, let this denote the greatest integer less than or equal to x, then fx is equal to this. If limit x approaching 2 minus fx is equal to L1 and limit x approaching 2 plus fx is equal to L2, you have to find the sum of the two, L1 plus L2. Okay, so let's write it down. You are given that fx is equal to 2x minus greatest integer function for 2x, where this x represents greatest integer function. Let's discuss this one a bit. So the greatest integer function of 2.2 will give you 2. Similarly, the greatest integer function of 2.9 will also give you 2. So that means you have to find out the nearest integer, the lowest possible integer for that. Okay, so now you are given L1 is equal to limit x approaching 2 minus fx is equal to limit h approaching 0 f of 2 minus h, which is limit h approaching 0 to 2 minus h minus 2 minus h, which will give you limit h approaching 0, 4 minus 2h minus 4 minus 2h. So we're subtracting something from 4. That means this will evaluate to 3. Limit h approaching 0, 4 minus 2h minus 3. This will give you 1. This is L1. Now let's go for L2. Similarly, L2 will be given by limit x approaching 2 plus fx, limit h approaching 0 to plus h, limit this. So 2 of 2 plus h minus greatest integer function of this. Okay. So this is limit h approaching 0, 4 plus 2h minus greatest integer function of 4 plus 2h. This is limit h approach. See, this is 4 plus something. So this will evaluate to 4. So you have 4 plus 2h minus 4, which will give you the answer as 2. You have to find out L1 plus L2. L1 was this and L2 is 0. So the answer to the question is 1. That means we have option A as the answer. Hope you understood this. Next is question number 66. It says limit, okay, this is the whole expression with you. You have to find out the limit when x is approaching infinity. Very first thing in the question, if I approach x is equal to 0, so this will be 2 raised to power 0 minus 1, that is equal to 1 minus 1, which is 0. And over here, this will be log of 1 plus 0, that is equal to log of 1, which is 0. So this whole expression is of the form 0 upon 0. Correct? That means I have to change it. This will be written as, this can be written as half into limit x approaching 0, 2 raised to power x minus 1 upon x whole divided by limit x approaching 0, 1 upon, sorry, this is log 1 plus x, 1 plus 2x, log 1 plus 2x whole divided by 2x. See, I have divided the numerator and the denominator with 2x. Okay. Into e raised to power limit x approaching 0, 1 plus sin x minus 1 multiply 2 upon sin x using L'Hospital's rule. Now, half limit x approaching 0, this will be 2 raised to power x into log 2 whole divided by limit x approaching 0, 1 upon 1 plus 2x. E raised to power limit x approaching 0, sin x into this. They will cancel out. So this will be half. This is x approaching 0. This will give you log 2 upon 1 into e raised to power 2. That's it. So this is equal to half of log 2 into e square. This will be equal to e square into log 2 raised to power 1 by 2, or this is e square into log root 2. E square log root 2 is the answer to the question option D. Hope you understood this. Next is question number 67. If fx is differentiable function such that f of 0 is 0 and f dash 0 is equal to 20, for x belonging to 0 to pi by 2, if this whole expression, if ax is equal to this whole expression, then the limit x approaching 0 for ax will be given by. First thing, fx is a differentiable function and you are given f of 0 is 0 and f dash 0 is equal to 20. X belongs to open 0 closed pi by 2. Ax, let's write down, is 2fx cosec 4x plus 4fx cos square x plus 1 minus 4 cos square x. Now, taking limits on both sides, limit x approaching 0, and I can also say here the limit x approaching 0. So this is using the L'Hospital's rule. Again, limit x approaching 0, 2 of fx whole divided by sine. No, I'm not using the L'Hospital's rule. I'll just simplify this. Cosec can be written as 1 upon 4, 1 upon sine 4x, 4 fx cos square x plus 1 minus 4 cos square x. Now applying L'Hospital's rule. This will be limit x approaching 0. Ax is equal to limit x approaching 0. 2 into this, right? Plus 4. I'll leave the rest as such. I will not. Okay. So let's simplify it further. You know, f of limit, when x is approaching 0, you have this 2 of f dash 0 upon 2 cos 0 plus 4 f of 0 cos square 0 plus 1 minus 4 cos square 0. F dash 0 was equal to 20. So this is 2 into 1 plus 0. F of 0 was equal to 0 minus 4. Cos 0 is equal to 1. So this gives you 20 minus 4. That is equal to, wait, I missed this 4 over here. This was not 2. This was 4. So this will cancel. And 10 minus 4, you have the 6 as the answer. Option C. Hope you understood. Let's move to the next question then. Question number 68. You are given if fx is equal to this, then f dash x is equal to fx into gx. You have to find that first derivative of g e. All right. So let's write, you have been given fx is equal to e raised to power minus x into sine x upon natural log of x. And fx is equal to gx product of fx into gx. So let's find out the first derivative of this fx. This is given by taking the square of the denominator into denominator. Derivative of the numerator, that's e raised to power minus x into cos x minus e raised to power minus x sin x minus e raised to power minus x into sin x upon x. Okay. Yeah. So that's it. This is equal to, I'll take e raised to power minus x cos x minus sin x whole divided by log ex minus e raised to power minus x into sin x upon x divided by log ex whole square. Also, you are given that gx is equal to f dash x upon fx. F dash x is this. This is f dash x. So suppose this whole thing e raised to power minus x cos x minus sin x whole divided by log of ex. This is divided by fx, which was, so I'll write log ex upon e raised to power minus x sin x minus e raised to power minus x into sin x upon x upon log ex. This is actually divided, no multiplied. I'm already writing it in the multiplied form. So e raised to power minus x sin x. Here, this will cancel and this will cancel and this will cancel. Sin x will cancel and here was log square x, right? And this will cancel. You will be left with, this is equal to cos x minus sin x upon sin x minus 1 upon x log ex. I hope you understood this. So this is equal to cotangent of x minus 1 upon log ex. Okay. Now, this is, we calculated gx. What we need to find out, the first derivative of it. So g dash x is equal to cotangent derivative is minus cosecant square x plus like one derivative is 0. So I'll leave it. And this is given by plus 1 upon x log ex whole square into the denominator. Okay, this is equal to x into 1 by x plus log x, because I have to find out the derivative of this. So this is minus cosecant square x plus 1 plus log x upon x log ex whole square. You had to find out g dash e. So this is minus cosec square e plus 1 plus log e and e into log e whole square. So this is minus cosecant square e plus, this is equal to 2 upon e square into 1. This will give you 2 e raised to power minus 2 minus cosec square e. This is the answer to the question. Let's check with the options. 2 e raised to power this, and this is option C. So option C is the correct answer. Hope you understood this question, right? Next is question number 69. If y is equal to this expression, then first derivative of y at 0 is okay. So this is not a tough question, but the thing is, it is going to be lengthy because the expression given in the question is a bit difficult. Students, before moving on to the question, here's a quick reminder to visit our website www.examsnet.com. There you will find this and many more entrance exam question papers of this similar type, which you can practice for your better performance. Also, you can download our app. The link is available in the description box. So here we go. We are given y is equal to e raised to power sine x plus sine h cube x whole divided by cos hx minus tangent of x. Now you have to find out, okay, first of all, let's simplify this. This is e raised to power sin x plus sin hx can be written as 1 by 2 e raised to power x minus e raised to power minus x whole cube whole divided by 1 by 2 e raised to power x plus e raised to power minus x minus tangent of x. Now, this is y. dy by dx is equal to. So now it's going to be a bit typical. So pay attention. Denominator square minus tangent of x whole square. And I'll write down the denominator 1 by 2 e raised to power x plus e raised to power minus x minus tangent x into the derivative of the numerator. Now, derivative of numerator is cos x into e raised to power sin x plus 3 by 8 e raised to power x minus e raised to power minus x whole square e raised to power x plus e raised to power minus x minus e raised to power sin x plus e raised to power x minus e raised to power minus x upon 8. This is cube. Okay, this expression will be multiplied with e raised to power x minus e raised to power minus x upon 2 minus secant square x. I hope you remember the formula for finding out the derivative. First of all, you have to square the denominator and then denominator into the derivative of the numerator minus numerator into the denominator's derivative. Okay. All right. So let's simplify this one further. See, if I'll simplify, it will take a lot of time. I'll just put on, we have to find out y dash of 0. So I'll just fill in the values now. So this will be 1 by 2 e raised to power 0 is 1. And this will give me, this is 1 by this. So this is equal to 0. 1 plus 0. 1 plus 0. 0 minus 1 whole divided by yeah. So this is whole divided by 1 by 2 into see, this was equal to 1 plus 1, so this is cancelled. I'll redo this one step again. So y dash 0 is equal to half into 1 plus 1 minus 0. Cos of 0 is equal to 1. This is equal to 1 into 1 plus 3 by 8 into 1 minus 0. This whole is multiplied with 1 plus 1, that is equal to 2 minus. So e raised to power 0, that is 1 plus 0. Then this is multiplied with 0 minus secant square 0, that's going to give you 1 again. Okay, so this whole thing is divided by 1 by 2, 1 plus 1 minus 1. Minus 0, sorry. Whole square. So this will cancel with this. You will have this as 1. This is also 0. So this will be 0 as such. So this is equal to 1 minus, this is 1. So this is equal to 1 minus 0 into 1 plus 0 minus 1 plus 0 into 0 minus 1 whole divided by 2. Right? 1, sorry. Okay, so this is going to give me 1 plus 1 upon 1, that is equal to 2. So 2 is the answer to the question. Option D is the correct answer. Hope you understood this. See, this sum was very easy. It was not tough. The only thing to be considerate over here is you need to be very much precise with your calculations, because a single mistake will give you a very wrong answer for sure. Okay, so the only thing to practice over here is practice and make all the calculations right. And of course, follow the formulas. Next is question number 70. It says the approximate value of this expression rounded to 3 decimal places is. You have, first of all, let's say 28. This is the cube root of 28, right? If I have to find out the cube root of 28, this can be written as 27 plus 1 cube root, right? If I say let x is equal to 27 and delta x is equal to 1, question number 70, the approximate value of this expression rounded off to 3 decimal places. Okay, so you have to find out the cube root of 28. Let's say, okay, first thing, 28 cube root can be written as 27 plus 1 cube root. Let's say x is equal to 27. And delta x can be written as 1. And I'm taking y as the cube root of 27. That is x. Okay. Now dy by dx. This is equal to 1 by 3 into x raised to power 1 by 3 minus 1, which is equal to 1 by 3 into x raised to power minus 2 by 3. Okay. X is equal to 27. Correct. Okay. So this can be written as 1 by 3, 27 minus 2 by 3. That is 1 by 3 into 3 raised to power minus 2, which is equal to 1 upon 27. Now, approximate value of this is y plus dy by dx delta x, that is 27 cube root plus 1 by 27 into this. So this is equal to 3 plus 1 by 27 is approximately 0.037 up to 3 decimal places. So this is 3.037. This is the answer to the question. 3.037 is option B. Hope you understood. Next is question number 71. Y is equal to x square is the given curve. You have to imagine that this curve is dragged along the x-axis to a distance of a units. If the acute angle between the curves at two positions is theta, then what is true about theta out of the four options? Now you are given that the curve is given by y is equal to x square. If the curve is dragged along the positive x-axis through a distance of a units, then the new curve will be given by this, right? So the point of intersection, we can say for point of intersection, you have x square is equal to x minus a square, correct? That means x minus a is equal to plus minus x, correct? There are two cases, x minus a is equal to plus x and x minus a is equal to minus x. See, this is not possible, of course. That means 2x is equal to a or x is equal to a by 2, right? At x is equal to a by 2, what is the value of y? Y is equal to a square by 4. So the point of intersection is point of intersection is given by a by 2, a square by 4. For curve 1, which was, let's take the two curves. Dy by dx is equal to, see, for the curve 1, we had y is equal to x square, dy by dx is equal to 2x, which is equal to 2 into a by 2, that's a. Okay. And the second curve, that is y is equal to x minus a square. This is for the second curve which is given. Dy by dx is, see, let's say this has 1 and this one has 2. This is equal to 2 into x minus a into 1. So this is equal to 2 into a by 2 minus a, which will give you this, that is minus a. Okay, now you have to find out the, now we are talking about the theta, that is the angle. Theta is the angle between the two curves at that point. So tangent of theta is given by the formula dy by dx of the first curve minus for the second curve upon 1 plus product of both of them. Okay, so this was equal to a minus of minus a 1 plus a into minus a mod. That's going to give you 2a upon 1 minus a square. So this is the answer, 2a upon 1 minus a square. This is the answer to the question. Let's check. You have option tangent. Okay, we have option B as the correct answer. Hope you understood this question, right? Let's move to the next question, number 72. Question number 72. If x and y are two positive integers such that x plus 2y is equal to 10 and x square y cube is maximum, then okay, then you have to find out this expression value. So you are given that x plus 2y is equal to 10, that gives you y is equal to 10 minus x upon 2. Now let's say this is equal to p. Correct? This is equal to p. Let's find out the first derivative. It's given this is maximum. So dp upon dx. This is equal to first function to derivative of second. So this will give you, first of all, let's fill in. This is derivative with respect to x, x square into 10 minus x upon 2 cube. Okay. Let's find out the derivative. This is equal to first function into derivative of second. So 3 into 10 minus x upon 2 whole square into minus 1. Okay. Yeah. Plus second function, that is this, into the derivative of first. Correct? This will give you, I'll simplify it, 10 minus x upon 2 square x. I'm taking this as common. So this will leave me with 10 minus x upon 2 into 2. See, okay, this is going, no, sorry. I can't do this. Upon 2 into 2 minus 3x. This is left. Okay. So this is equal to x into 10 minus x square upon 4. This is going to cancel 10 minus x minus 3x. That's equal to x into 10 minus x square, 10 minus 4x whole divided by 4. Right. I think I'm doing it fine. Question number 72. If x and y are two positive integers such that x plus 2y is equal to 10 and x square y cube is maximum, then x square plus 2y cube is equal to. Fine. You are given x and y. They are two positive integers and x plus 2y is equal to 10, which gives you y is equal to 10 minus x upon 2. And let's say this is equal to p. So let p is equal to x square y cube. You can write down p as x square 10 minus x upon 2 cube, which gives you 1 upon 8 into x square 10 minus x cube. This is equal to p. Let's find out dp upon dx. So dp upon dx, you know the first function, 1 by 8 will come outside. So I'll write down the first function like this, 10 minus x cube into the derivative of second minus 3. This is going to give me 3x square 10 minus x whole square, right? I'll take x into 10 minus x square outside. I'll be left with the 2 into 10 minus x minus 3x, which will give me x upon 8, 10 minus x square. So 20 minus 5x, right? This is the derivative of p with respect to x. Now, for it to be maximum, for p to be maximum, this derivative should be 0. That means x upon 8, 10 minus x square, 20 minus 5x should be equal to 0. Now, the three possible values for x are x can be 0, x can be 10, or x can be 4. 0 is not possible because you are given that x is positive integer. So only two possible values are there for x, that is 4 and 10. Now let's find out the second derivative of it. So d square p upon dx square is equal to 1 by 8. Now I have three functions, 1, 2, 3. Let's go for this. So 1 by 8, 10 minus x square, 20 minus 5x plus x into minus 2, 10 minus x, 20 minus 5x minus 10 minus x square into 5. Okay, so that's it. Now, let's say at x is equal to 4, let's find it out. What will be the value of d square p dx square? At x is equal to 4, you will evaluate. Let's go. So this is going to give me 6 squared, that is equal to 36. And this is going to give me 0 actually. Plus 4 into minus 2 into 6. And this is also 0. So 6, this is 36 into 5. So that will give you 136 multiplied by 8 minus 36 multiplied by 8 upon 5. That means it's a negative value. So that means x is equal to 4 is the point of maximum. Right? Let's find out the value for y then. Y was equal to 10 minus x upon 2. That means it is 10 minus 4 upon 2 or 3. Correct? You have to find out the value of x squared plus 2y cube. To find was x squared plus 2y cube. So x is 4 squared plus 2y cube. That's 16 plus 54. 70 is the answer. Option D. Hope you understood this question. Let's move to the next question, number 73. If 3 pi by 4, if x lies between 3 pi by 4 and 7 pi by 4, then the integral of this whole function is equal to. Okay, let's write it down. You are given that integral of 2x minus root of 1 plus sine 2x plus 1 upon x square minus 1 upon x dx, where x is lying between these two values. Correct. So this is equal to integral of 2 raised to power x. 1 plus sine x can be written as sine x plus cos x whole square. You know this. Plus 1 upon x square minus 1 upon x dx. So this is equal to integral of 2 raised to power x sine x plus cos x, right? The square root and the square will cancel each other. Plus 1 upon x square minus 1 upon x dx. So this is equal to 2 raised to power x plus sine x plus cos x, this, and dx. Right now, simply you have simplified the expression a lot. Now we'll just find out the integral. 2 raised to power x integral is 2 raised to power x upon natural log of 2 minus cos x plus sin x. 1 upon x squared, the integral is minus 1 upon x, and this is log e x plus the constant c. So this is the answer to the question. Let's check with the options. 2 raised to power x upon log 2 minus cos x plus sin x. This is answer C. Option C is the correct answer. Hope you understood this. Next is question number 74. If tangent of alpha is 4 by 3, then you have to find out this integral. See, if tangent of alpha, you know one thing, tangent is perpendicular upon base. So this is 4 by 3. If this is 4 by 3, then this is equal to 5. This side is equal to 5. So tangent alpha is 4 by 3. Cos of alpha will be equal to 3 by 5 and sine of alpha will be equal to 4 by 5. Now you have to find out this integral. Let this be I. So you have to find out 1 upon 3 cos x minus 4 sine x dx. Let's multiply the numerator and the denominator with 5. So you will have 1 by 5 will come outside. This is 1 upon 3 by 5 cos x minus 4 by 5 sin x. Now, I hope you know why I have done this, because I want to get into these two terms. This is equal to 1 by 5 integral of 1 upon 3 by 5 is cos alpha. So cos alpha into cos x minus sin alpha into sin x dx. This is equal to 1 by 5 integral of, this is cos x plus alpha dx. That is 1 by 5 secant x plus alpha dx. That is equal to 1 by 5 natural log of tangent of pi by 4 plus alpha by 2 plus x by 2 plus the constant c. Okay, so this is the answer to the question. Let's check with the options. You have option B as the correct answer. Hope you understood this. Next is question number 75. If x is not equal to 2n plus 1 pi by 2, then you have to find out this integral function. Sorry. Okay, so now you have to find out this. Let's write it down. Cos cube x 1 plus sin x raised to power 4 dx. This can be written as cos x into cos square x, and cos square x can be written as 1 minus sin square x upon 1 plus sin x whole raised to power 4 dx. I'll put 1 plus sin x is equal to some t, which gives me the derivative cos x dx is equal to dt. Okay, so now the integral will become 1 minus, okay, yeah, cos x dx, wait, cos x dx, this will become dt. So this is equal to 1 minus t minus 1 whole square upon t raised to power 4 dt. That's equal to, let's open it up, and you will have minus t square minus 1 plus 2t plus 1 whole divided by t raised to power 4 dt. These two will cancel, and you will have integral of minus t square plus 2t upon t raised to power 4 dt. So this is equal to integral of minus 1 upon t square dt plus 2 will come outside, 1 upon t cube dt. Right? So this is equal to, this will be equal to 1 upon this. See, this 2 and this will be multiplied by 2. These will cancel out. Okay, and a minus will be introduced over here. And this one will be, this was minus. So minus 1 upon t multiplied by 1. This is going to give me minus 1 upon t square plus 1 upon t plus the constant c. Okay, now let's fill in the value for t. This can be written as t square over here. So this is minus 1 plus t plus this, which is equal to t minus 1 upon t square plus t. So now the value of t was equal to sine x plus 1. So this is equal to sine x upon sine x plus 1 whole square plus the constant c. And this is the answer to the question. Let's check with the options. Sine x upon 1 plus sine square x upon t. Sine x upon 1 plus sine x whole square. This is not present in the options, so we have none of the above option E as the answer to this question. Hope you understood. Let's move to the next question then. Question number 76. Given that limit n approaches infinity 1 by n, sigma summation r from r is equal to 1 till np, f of n f of r upon n is equal to this integral. If f is a function from real numbers to real numbers is defined by fx is equal to x squared plus 2, then you have to find out this expression value. So let's write down, you are given n approaches infinity 1 upon n summation from r is equal to 1 till np, function of r upon n is equal to integral of 0 to p fx dx. Right? Also, you're given second thing, f is a real to real number function and given by this expression. Now, limit n approaching infinity. You have to find out this 3 upon n, f of 7 upon n plus f of 14 upon n plus f of 21 upon n till f7 is equal to what? Let's write it down. Limit n approaching infinity 3 by n. Now, this function is given by, do you remember, x squared plus 2? That means this will be written as 7 upon n square plus 2 plus 14 upon n square plus 2 plus 21 upon n square plus 2, so on till, see, 7, this can be written as 7n upon n square plus 2, right? Whole closed. Now, this is equal to, see, over here, I'm adding 2 how many times? N times, right? So this will be written as 2n plus 7 upon n whole square. I'm taking this as common. 1 plus 1 square plus 2 square plus, see, from here you will have 3 square, so on till n square. Correct? This will become now limit n approaching infinity 3 upon n, 2n plus 49 upon n squared. You know the formula for this squaring. What is the formula? Let's write it here. The formula is given by, I'll write it on this side only. So this is n into n plus 1 into 2n plus 1 whole divided by 6. That's equal to limit n approaching infinity 3 upon n, 2n plus 49 upon 6. I'll do one thing. I'll divide it with n. Okay, so this will be n square into 1 plus n to 1 plus n. Okay, this whole closed. I hope you understood over here. So what I did, this n, I took it inside. This one n, I took it inside, and this becomes 2, and this n will cancel out. And I'll have taken n common from here. This and this as well. So this is the common one. Question number 76. Given that limit n approaching infinity 1 upon n summation r from r is equal to 1 till np, f of r upon n is given by this expression, integral of 0 to p fx dx. Now, if f is a function from the real numbers to real numbers and is defined by x squared plus 2, then this whole expression is equal to what? All right. You are given these two things. And this is the second one. And also the f is a real function from real to real function. Now, this is fx is equal to x squared plus 2. Let's write down what we have to find out. Limit n approaching infinity 3 upon n function of 7 upon n plus 14 upon n plus f of 21 upon n till f7 is equal to what? You have to find out. This can be written as limit n approaching infinity 3 upon n. F of 7 upon n. Using this particular function, this will be written as 7 upon n square plus 2 plus 14 upon n square plus 2 plus 21 upon n square plus 2. So on, this can be written as 7n upon n square plus 2. Okay. So this is equal to limit n approaching infinity 3 upon n. See, there are 1, 2. How many n's are there? There are 2 n's. N times 2. Okay. So this can be written as 2n plus I'll take 7 upon n square common from here. This is equal to 1 square and you will have 2 square from here, 3 square from here. Similarly till n square. Now there is a particular formula for summation n square, that is equal to n into n plus 1 into 2n plus 1 upon 6. That is limit n approaching infinity 3 upon n to n plus 49 upon n square into n plus 1 into 2n plus 1. I'll take the this n inside, limit n approaching infinity. This will be 3 will be outside, 2 plus this n and n cancel. This will be written as upon 6 is there. 49 upon 6, 1 plus 1 upon n into 2 plus 1 upon n. I have taken n common from these as well. So they will also cancel out, these ones. Okay, so they will also cancel out. Now let's fill in n approaching infinity. This will be 3 into 2 plus 49 upon 6, 1 plus 0, 2 plus 0. That is equal to 3, 2 plus 49 upon 3. That will give you 55 as the answer. So you have option A as the answer to this question. Hope you understood this question. Next is question number 77. You are given fx is equal to this particular matrix, then integral of 0 to pi by 4 to fx plus 5 integral of first derivative of fx is equal to what? This is fx. Right now applying, doing some operations. Second row is second row minus 2 cos x into R3. This function will be now 2 cos square x sine 2x sine x. This will be sine 2x minus this. So that's going to give you 0. And 2 minus cos x. Okay. And this one will remain as such, sin x minus cos x and 0. Now expanding along R2. Along second row, you have fx is equal to 0 plus 2 into 0 minus sine square x plus cos x minus 2 cos cube x minus sin x, sin 2x. That will give you minus 2 sin square x minus 2 cos square x sin square x plus cos square x minus 2 sin square x minus 2 cos square x, which will give you minus 2, right? That means the f dash x, it's simply 0. Now let's go with the integral we have to find out. Zero to pi by 4 fx plus 5f dash x dx. This is in integral 0 to pi by 4, 2 into, see, this is the this is function, so this will give you minus 2 plus 5 into 0 dx. That's going to give you 2 into 2. This function will give you 2, so this is 4 plus 0 dx. That will give you simply 4x, 0 to pi by 4. So 4 into pi by 4 minus 0 will give you the answer to the question as pi. And we have option D as the correct answer to the question. Hope you understood this. Let's move to the next question, number 78. The number of arbitrary constants that appear in the general solution of this differential equation is. So you are given this differential equation. Let's do the squaring on both the sides. You have d raised to power 4, not d raised to power 4 actually. It's a fourth derivative of y with respect to x plus this cube is equal to 5 this third derivative square. So this is d4y dx4 and d square y dx square whole cube is 25 into this. Right. So what is the order over here? It's 4. Right. So the number of arbitrary constants is also 4. Hope you got that. So we have option A as the answer to this question. Hope you understood this. Let's move to the next question, number 79. The degree of the differential equation, this is equal to 0 is 2. All right, this is the assertion which is given to you. Okay. And the reason is the degree of a differential equation is the highest degree of the highest order derivative occurring in the equation after the equation is expressed in the form of polynomial and the differential coefficients. Now, the correct option over here is not. Let's understand the reason once again. The degree of the differential equation is the highest degree of the highest order derivative occurring in the equation after the equation is expressed in the form of polynomial in the differential coefficients. This is the given one. Question number 78. The number of arbitrary constants that appear in the general solution of this differential equation is. See, here you are having the power as 3 by 2. So first of all, rectifying this. Squaring on both the sides, you will get fourth derivative of y with respect to x plus second derivative of y with respect to x whole square is equal to 5d cube. That's the third derivative of y with respect to x square. So d4y upon dx4 plus d square y upon dx square is equal to 25 into this. Right. So here the order is 4. That means the number of arbitrary constants is also 4. Right. We have option A as the correct answer. Next is question number 79. Assertion A, the degree of the differential equation, this is equal to 0 is 2. The degree of the differential equation is the highest degree of the highest order derivative occurring in the equation after the equation is expressed in the form of polynomial in the differential coefficients. Now you have to choose the correct option among the following. Now, if I take this one, you have y second derivative plus 2x y dash plus log e dy by dx is equal to 0. So here you are having the derivative at log e, log to the base e with the derivative. That means this degree is not defined. Okay, which simply means that your assertion is wrong. But the reason is, of course, true. Reason is absolutely fine. The degree of the differential equation is the highest degree of the highest order derivative occurring in the equation after the equation is expressed in the form of polynomial differential coefficient. Since this is not expressed, so reason is correct, but assertion is false, which makes option D to be the correct answer to the question. Hope you understood this. Next is question number 80. Let S be the family of curves given by the general solution of the differential equation this. Then the equation of the curve belonging to S and passing through this point is given by. You are having y square e raised to power 1 minus y upon root of x dx minus 2 secant root of x dy is equal to 0. If I write it as the dx upon dy, this is equal to 2 secant root x into root x upon y square into e raised to power 1 by y. So I'll take I'll segregate the dx and y terms on one side and x terms on one side. This will make e raised to power 1 by y upon y square dy is equal to secant will make like 1 upon secant, it will make cos. So this is cos root x upon 2 root x into dx. So this derivative is integral, sorry. Integral will give you e raised to power minus e raised to power 1 by y. This is equal to sine root x plus the constant c. Now you are given that this passes through pi square comma 1. Curve passes through pi square comma 1, which makes it minus e is equal to sine pi square root is equal to pi. So sine pi plus the constant c, which makes sine pi is equal to 0. So that makes c is equal to minus e. So s is e raised to power minus 1 by y is equal to this, or sine root x plus e raised to power, sorry, this is minus over here, not here. So e raised to power 1 by y is equal to e. This is the answer to the question. Sine root x plus e raised to power 1 by y is equal to e. That is option C. Option C is the correct answer to the question. So students, with that, we have finished all the 80 questions, mathematical questions of this paper. Hope you understood them well. A very best of luck for your exams. Hope this paper, and do explore our website to visit other papers as well. You can explore it on www.examsnet.com. You can also download our app. The link is available in the description box. So best of luck, students. A very best of luck for your exams. Keep exploring, keep shining, keep rising high. That's all for this paper. A very best of luck. Bye.